And we are live. Welcome, everybody, to the 2021 WebXR Developer Summit. My name is Ben Irwin, and I am so happy right now. I can't tell you, because for the last 6 months, I have been working with some of the greatest people that I've ever worked with. They're not just amazing XR folks, they're amazing human beings. And together we made the Poly's WebXR Awards. And we also have, for the last couple of months, been planning the WebXR Developer Summit to bring everybody to the table so that you guys aren't just GitHub repos to each other anymore. You are flesh and blood human beings with ideas, and we're here to talk about the future. We're here to talk about the tech stack, and we're here to talk about the content. So why are we doing this? Well, WebXR is not just an important technology of our times. It is perhaps one of the most important technologies that humanity has ever come up with. And it's at the very, very beginning. Why is it so important? Because we are on the open web, and JavaScript developers, 12 million of them, which is as many as there are C++ and C# developers combined. They're sitting, most of them, heads down right now, not even knowing that there is an immersive web. And for the last couple of years, you guys who know about this have been building it. But we're here to talk about the next couple of years. When these devices hit the market, we're going to be prepared, because the web is going to be the way to distribute 6DoF XR content in AR and VR. And so what can you expect from today's sessions? Well, we are going to have some really deep technical dives. We've got a low-level stack panel. We've got the W3C here to talk about the WebXR device API specification roadmap, including its core and its modules. We have Mr. Doob, the creator of 3JS, and we have Diego Marcos, the creator of A-Frame. And at the finale of the day, we have Active Theory, the agency that created the amazing Secret Sky experience that completely blew the doors off what anybody thought was possible in WebXR or even XR, by getting 200,000 unique visitors, 500,000 sessions, and 50,000 of those were in VR. They built that on the Dreamwave platform. So we have a special feature where they talk about exactly how they pulled that off. Then they're going to be here for a panel talking about it. And so those are just among the exciting things that are about to go down. So we've been working really hard on this. We want to thank our sponsors, FutureWay, which we couldn't be happier that they found us, because FutureWay is all about open source standards and collaboration. They're here to build the ecosystem of WebXR. So they've got a lot to offer you. So pay attention to what FutureWay is doing, because they are philosophically aligned with the mission of WebXR, and they're here to help. So thank you to Daniel Lundgren and Mats Lundgren for being our Galaxy sponsor for this. I would also like to thank Tom Fisk of the Immersive Wire, Zapper, MetaPrime, and the extended collection. We have a sponsor board full of names of speakers that will be here all day. We'll be dropping those, but I'm a little short on time here, because I'm just here to open the show and buy a little time and welcome all of you coming in from around. This show is watchable on YouTube. It is streaming on Twitch at twitch.tv/WebXR Summit all day. And speaking of the day, this morning session that we're on is going to end at 3:15 p.m. Eastern. Adjust for your time zone. After the Zapper panel, before the entertainment panel, and we're going to switch feeds because the streaming platform needs to toggle to make that happen. So we have watch parties in the multi-metaverse. VR Land has a watch party. Matt Cool set us up with a Hubs watch party. We have the Poly's world premiere that Cause and Christie World Builders built for us that is just absolutely gorgeous and stunning. We even have an Engage watch party, and XR Women is streaming this into iLearn. So what more can I say? Well, I'm not here to talk. I'm going to be switching the show all day. So I'm going to bring on our host, pillar of the WebXR community, and just another amazing person to work with. So happy to have you here, Trevor. Welcome, our host of the WebXR Developer Summit, Trevor Flowers. Take it away, my man.
Hey, everyone. Thank you, Ben. Yes, I am so excited. Like Ben said, we've been working with just people throughout the community. We had a town hall to sort of hear from the community what we should even talk about today. One of the great problems we have is that there's now more happening on the immersive web than we can fit in a one-day event. So we had to reach out to a lot of people and sort of hear what was important to you. And the general theme of the day is to look at where we are right now as a community, to look at sort of how we've come to the point that we are, the things that we can do now, and then also to look forward a little bit, to look forward and see where there are gaps that we need to fill in the next year or two, and then even the vision of where we want to be even longer term. So I'm really excited about the people that we have scheduled to talk today. I think my job will be relatively easy because there are a lot of really smart people who are doing incredible work. So my job is just to tee them up with the good questions and then let them run with those answers. But I do have a little bit of work to do before we can jump into that. And that is to sort of set the stage so that we're all kind of on the same page about what. Hi, Ricardo, everyone at the event today. Not sure that was supposed to happen, but so one thing I will do today is sort of set the stage and say, here's the broader context of what we're talking about. And I'll sort of cover some of the key terms so that as people throw them into the interviews, you're on the same page with what they mean and where they fit into the big vision. And I'll just take a few minutes to do that. Don't worry, it won't be very long. We will be going into the interviews and the panels as quickly as possible, but let's just do a quick 3 or 4 minutes about the context. So, okay, we all have different terms for this. We have the immersive web, we have the metaverse, we have WebXR, we have spatial computing. I use this term called the wider web. It means some very specific thing, but we're all generally talking about the same thing. But I wanted to sort of take a few minutes to talk about this because I think it's a handy frame. There's 3 parts to the wider web when I talk about it. There are the display modes. So in the past, we've had one display mode, which is basically flat screen and a little bit of change. We have control types like keyboard and mouse and things like touchscreens and now wands and voices. And then we have different types of controls or page controls, overlay controls, or now spatial 3D controls. So there's sort of 3 big parts, and I'll go through each of them. Okay, so we have these 3 display modes. Like I said, for a long time, the web was just flat. We had CRT sitting on desks, and then we added another flat type, which was the smartphone and the tablet format. And we did a lot of work for more than a decade to come up with responsive design that handled smoothly changing between those 2 types of flat displays. And that took a ton of work. And all of the complexity of CSS and the complexity of media queries that let you do different things for different kinds of flat displays, those core ideas actually set the web up to be in a good place as we now merge into 2 additional display types. That being the portal display and the immersive display. So the immersive display is what you think of when you think of VR or AR glasses. Those are things you wear on your head. They're either see-through or opaque. And so a lot of the people that we'll have on today will talk about immersive displays as their sort of default when they're talking about WebXR. But the thing to remember is that when we designed WebXR, we specifically made it to be responsive and to handle whatever hardware people showed up with. So if they show up with a smartphone, they can view the content just on the regular flat display. They can use it as a portal into a space by holding it up and getting those types of motion information. And then immersive displays, of course, are either here today for VR or a little bit further out for AR. So that's one aspect of the wider web. The The next aspect is that in addition to having those display modes, now we have 3 control types. So we have sort of in-page controls. That's what you think of when you think about normal HTML with buttons and links and text and images. Those are called page controls. And then if you're in the portal mode with your handheld and you're looking into a space through a flat screen, those are overlay controls. So those are controls that seem to sort of sit on top of the world. And then for both portal mode and for immersive displays, you have spatial controls. And so there's a whole industry and literature of industrial design that teaches us how to make 3D tactile controls in the world in 3D. And so we're bringing in this whole new genre of design capability for spatial controls. One theme that you'll notice is that with the wider web, we're adding complexity. So all of the complexity of responsive design for the flat web is now being sort of exploded, becoming exponentially more complex, because we're not just designing for a couple of flat modes in all page controls. We're designing for 3 display modes and 3 control types. And the third part of it is new input types. So not only is what we're showing, but the interaction that we're talking about on the wider web is vastly more complex. We're tracking hands now. We're tracking wands or the kinds of controllers that you get when you buy a VR headset. And then also we're listening to voices. And then coming down the pipe, we have things like eye tracking and the facial tracking. So we actually are tracking the expressions that you have on your face. These all combine together into this thing called the wider web, and it's sort of vastly complex. And so that is what we will be talking about today, where we are today with immersive browsers, where we are today with web APIs, and where we are today with the tool chains that sort of fit around all of that. And so I won't go through all of this, but this is, within the context of the web browser, there's sort of several layers of technology that we talk about. At the bottom layer, you have the hardware. You have smartphones and PCs, XR glasses, or wearables like watches. Above that, you have the browser that provides the web APIs. So I'll go through a few of these because we'll talk about them a lot today. WebAssembly is basically a faster way to run code than JavaScript. So it has a lot of other capabilities that it brings to the table, but for XR, the thing to remember is that it lets us write code that runs at native speeds. JavaScript has typically been a little bit slower than if you write in a native language like C++ or Rust. WebAssembly brings those speeds to browsers. WebXR is the API that lets the browser talk to headsets and get information like information about the environment, like planes and things like that. Web Audio brings spatial audio. WebGPU lets us display graphics quickly. And WebRTC is all about communicating between the browser and servers or other browsers. Got the graphics engines. We'll talk about those today, physics engines. And then above that, you have app frameworks like Three.js or Babylon or Potassium ES. And these are engines that sort of wrap it all up and make it so that web developers don't have to know about all of the complexity of these things. And then on top of that is the application code. And so later in the day, we'll talk about education and privacy and lots of different advertising, lots of different sort of applications that we use. And finally, there's all the services. So I'm going to wrap this up by just saying, a lot of the work that has gone into XR today is about making sure that the browser is capable of doing XR, but there's a whole set of work around services like geolocation and shared content and digital bodies and how do we take identity from service to service. All of those are sort of the final piece. And that is what we will be talking about today. As if that wasn't enough, we'll have people in from each of the browser teams and a lot of the libraries, and so we will cover that. So I know that was a bit of a whirlwind, but those are the key words and sort of the way they all fit together for today. And I think what's coming up next is we will have Mr. Doob, or he is the author of the 3JS library. And I recorded an interview with him earlier in the week where we are sort of go over the history and the source. And so we will roll that video and then the history. So yeah, let's just go roll into that, and then we will bring him on live for Q&A after that. Hi, Ricardo. Thank you so much for being here. I really appreciate you coming and talking to everyone at the event today about the history of your involvement with the immersive web, what we now call the immersive web, and the future. Thank you for being here.
Yeah, thanks for inviting me. It's a pleasure. Great.
I think one of the things that I think it's safe to say is that the community around 3JS is one of the biggest, sort of graphics engine communities on the web these days. Mm-hmm. When you started the project, did you have any idea that there would be this many people who were involved and that you would see this kind of growth in interest and in contributions?
I didn't. Somehow my main thinking was like I wanted to solve the problem. I wanted to have a tool. The tool, it was mainly actually the tool is something I wanted to have for myself, and I wanted to solve that problem. And somehow like more and more people kept like contributing, but I was not thinking like, oh, what was going to happen, like in this time, like a lot of people rely on it, and that's something I'm still like getting used to it, to like, the responsibility of like making a change that can break things. But it's been pretty challenging, and it actually has been like something that is one of those things like, there's no like, it's kind of probably a good thing that I didn't go to university, because also there's no like university, like there's no school where they teach you how to run communities, how to run like open source. You just find yourself doing it, and if you have patience, and you're lucky to have patience, and you can do it, then you just do it. But yeah, it's been like a pretty like everyday discovery. Like, oh, now there's these people fighting. I had to learn how to like, how to de-escalate conflict, and like try to like encourage people to like contribute or like make things easier, and like really considering also that I'm not like, my background is not really software development. I'm making it very trying to make it very easy for people to contribute, which sometimes what means that there's a lot of contributions. But I think it got into the point that it's not that easy to contribute, because the things that need to be done now are much harder. So right now, I think it's getting to a point that is fairly stable, not that crazy. For the last 5 years, so it was pretty intense.
Yeah, one of the things that I was wondering was the sort of shift that you've seen in the types of problems that you have to solve to enable the rich interactivity of the 3JS engine. So when you started in the early 2010s, I think you said, what's sort of the difference between the things that you had to solve back then and the types of problems that you see the community facing today?
Well, things have been changing, especially since WebVR and WebXR. Things have changed quite a bit in like interactivity-wise. Like there's also WebGL and WebGPU coming that basically makes things faster. But at the end of the day, it's just a different way to talk into the GPU. Is not, just refactoring code doesn't require much. It's hard. Like you have to like figure out how to like do it the right way. But it's not gonna. Like ideally, like users are not going to even notice that work was done. It's just something that should be transparent and should be like, oh, now it runs faster. But at the beginning, it was mainly, controllers have, I guess, from the 2010s, for the 2000, like we, since most of the time on the web we only use keyboards and mouse. But now with WebVR, we also have controllers, and those controllers like basically make websites that allow you to control it differently. Well, I guess we also have like joysticks, but joysticks and gamepads, but we really, you don't use gamepads and joysticks for controlling a website or like interaction. Usually it's for a game.
Right.
But since WebVR, like with the first controllers, and also like the mix of like controllers, of the first ones being like 6 degrees of freedom, then like 3 degrees of freedom for like mobile ones that you had to like for all this process, all these years that we've been like, how do you make an abstraction of something like a 3 degree of freedom controller that also works with the same way like a 6 degree of freedom, and the UI, how do you make all these work for all these controllers? And I guess we are at the point that I think we can just ignore all the all these mobile like 3 degree of freedom controllers that it was something that's kind of like for getting up to speed, like since the Quest now it's all wireless, we can have 6 degree of freedom controllers. So now the challenge, and now like I guess since last year, especially like since last month, now we can use hands directly to interact with these worlds. So the new challenge is basically figuring out, like at the beginning was like fine, you can click on objects and you can just use your mouse and click on top of them, but now especially with hands, you basically want to grab them and like touch them, and you want to be more physical. Even if you don't have like a feedback, you want to be able to like. That's kind of that's the way that I think the future is going to be. Like especially now with VR, but like with AR is going to be the same thing. You're going to have things floating, and you're going to interact with them with your hands. Like I've been like usually like for the last month I've been basically using the Quest without controllers at all. It's only been using hands. I'm getting used to that.
Yeah, it's a big shift, right?
Yeah. So that's I think that's the problem or the interaction to solve, and somehow like make it like if it's clickable with your hands. Also, you need to work also with controllers, and some probably not with the mouse and mouse and keyboard, but that's that's a new abstraction that needs to be done, and needs to make. And I'm trying to make it easy for people that want to like create a like interface like that. But yeah, it's a bit more difficult than not just clicking on things.
Right. Yeah, when I first started thinking about wider web design, I just ran a sort of a thought process to see, the difference between designing a flat website with just a few actions and then basically the same type of experience, but with supporting all of the different input types like voice and touch and tracked controllers and hand input. And, it's an exponential amount of complexity for that sort of design.
Yeah.
It's interesting to hear that what started off with 3 being mainly centered around WebGL and display, it sounds like it's sort of expanding out to more of the sort of interaction mode. And obviously there's the shift to going into VR mode and AR mode using different kinds of displays. But it sounds like there's also big chunks that are sort of either landing beside or in 3JS. Other than that complexity of input, are there any other chunks that you see coming down the road for 3JS?
There's also in parallel. There's also the since the GLTF file format kind of specifies like this is a model that's going to have this type of like reflection and this kind of like roughness, and it's something that like websites like for instance Shopify they're using it for like showcasing, like if someone wants to buy a product, they can see it in 3D, and they really want to show the product as more accurate as possible. So with GLTF, that kind of enabled that like standardize all these this way of displaying all these 3D files. There's also more people that are interested in improving it, so adding more features to the format. So like until now it's been mainly like reflecting an environment or reflecting or an object that you can have reflective. But now you can make it. They're trying. The things that we had to add is to make it also like materials that can be transmissive, which means it's just like transparent, but also like it has to be refractive. So you have to like bend what is in the background, like and all of things like that. That is like when I started it was for me, it was impressive to have shadows.
Yeah.
Like an object actually had shadows on the floor, like on other things. Like at this point, it's like, wow, yeah, we can actually have like, like an object that is refractive, and I kind of know how the whole process is, but yeah, they keep adding more features into it, that because we also like render, those GLTF, we also have to make sure that everyone, like, we render it properly. So we also, it's things that whatever they decide that they want to add there, we also had to add to the engine too. Yeah, mostly those things, and keeping it optimized and trying to make it performant. But also the beauty of like open source and like is that I don't know like what people are going to contribute tomorrow. Like there are things that I wouldn't even think of. But yeah, like some of the things are also something I started like few months ago, which is like creating USDC files, which iOS uses for like the AR mode. So until now, we had to like have a GLTF file and a USDC file for being able to do AR. But like looking at the API that they were providing, I realized that we could actually generate those USDC files like on real time, like at click time. So it's something that worked out, and then these people also like seem to be using it, and they're also helping to make it more robust. So we support all the features. But
one of the things that is the topic of the day is what we need from the rest of the community to sort of step from where we are to take a big step forward towards a more immersive web, a more capable web, using these technologies. From your position, looking at the Three.js community and looking at both your personal projects and what you see a lot of the consumers of Three.js doing, what would you ask from the browser teams and the operating system teams and other library developers? Like, what do you see as necessary for us to move forward and sort of take the next step on the immersive web?
I think the browsers that are implementing the APIs are actually doing a very good job of like being ahead of what the libraries are doing. Like for instance, like we are not waiting for Oculus to add things. They keep adding more things, and that they keep adding things that I don't have time to study them and understand them. Yeah. So that's, I think the OS and browsers are doing a really good job of like keeping that up. The only thing I can think of is like in general for the community, like I think I noticed that we spend and I guess this is more of a software engineer kind of issue. Maybe we don't have tools for like designers or creatives, but I think there is a lot of, because right now like we rely on like programming, and someone needs to like program it. We tend to mainly focus on optimizing the experience of development. So there's a lot of like, oh, now we can do this, and with 3 lines of code, and like 2 lines of code, and like we can combine this and that. But there is not. But I wish there were more actually experiences that create that makes you laugh or like cry or like create emotions, like more experiences that like to become like viral. I think we need more projects that are like you had to go to this website, you had to like get this Oculus and try this thing, and you're gonna have a great time. I think we need more of that, like than not like libraries that make things easier. Because
over the next 2 years, what is your biggest hope for Three.js and the immersive web in general?
For 2 years, I think I want to I think it's mainly hoping that whichever abstractions we end up doing right now for interacting, like doing interaction in immersive environments, pan out to be to work well with whatever new headsets we end up having in 2 years. I think we're in the point that I can see that being like I don't want to do an abstraction that then like in next year like no, actually the controller is going to be different, and that's not useful. But I think I'm fairly confident that hands are going to be the thing, and controllers, but mostly hands, I think. So hopefully in 2 years we are having AR classes and we're using our hands, and everything is, and the same code that we have been doing since now is just working, and people are used to it, and people have been improving to it without having to like start from scratch again. That's my main hope. It's working fine. It's just there is no bet on the rendering side. Like we just keep adding features and you can just modify them, but like betting on like I think that's going to be the interaction. So that's going to be the abstraction that we need. That's I guess I spent like 2 years with WebVR, and then like it changed to WebXR, and then I had to like start again. So I don't want to have to do another one like that.
The second try is enough tries. Hopefully we'll stick with that one.
Yeah, and we are in a similar situation where sure, like for VR it's fairly easy. We use hands, we use controllers, but for AR like we're still using like touching on a screen that throws a ray that actually doesn't map with like hands, like it's so, and that's I think it's a temporal thing. So I don't want to invest too much time on that kind of interaction because I think that's something that's not going to last that long. That's just my what I think. So it's difficult to like be in a situation where, like that's helpful for one of the projects that is now, but like we'll see. Hopefully, I think it's going to be more hands. We'll see, but. Yeah, I just don't enjoy doing code that I had to like throw away that often.
Right, and that is for a long time. That has been the value of Three.js is that it helps people in some ways surf the radical changes that have taken place on the lower level pieces that allow them to do the experiences and to create the experiences. Well, thank you so much.
Yeah. My pleasure. Anytime.
All right. We are back. Hello.
Hi there. Long time no see.
Long time. Yeah. Thank you for coming back on today. So one of the things that we are doing is that we're using a tool called Slido to gather questions from the audience. And so Julie Smithson, I think, will bring up a Slido screen for us that has some questions, or she will somehow relay those to us. And then we'll go through and see what's going on there. Okay. So how important are no-code designer-centered tools for the future of WebXR? Yeah, that's a great question. Yeah. Have you had an experience? What's your take on that?
I'll say very important, which kind of ties with what I was saying, that we need more. Like one of the things that Flash had was that it was very easy. Like you didn't need to code for it, and that allowed a lot of people to do very silly things. And silly things are funny, so I think we need more of that. So, but it's also very difficult to do no-code design-centered tools. Like you can do something that works, but then they're going to add features like the set of features that they ask. People are going to ask is endless. So, I think it's better just to start with code and then build tools on top.
Yeah, I think one of the advantages of the web is that every website tool, no-code tool or otherwise, doesn't have to be everything to everybody. Like you have a package like Unity. They are trying to sort of be everything to everybody in a lot of ways, and they do a great job at what they do, but I'm looking forward to having the overhead of creating experiences be so low that we can have very niche tools that do specific things and don't have to sort of be general purpose. And then they all interlock through web standards. I know
combining them is also like kind of tricky. Like it's like I haven't seen a lot of, unless it's something like the React ecosystem where you can do many components and they work together. It's difficult to do something that you do something that someone using Angular can use it, and someone using React can use it, and someone using a visual editor can also combine it. That's a bit challenging.
Certainly. Yeah, we have a little bit of interconnect through GLTF, the file standard, but the higher level interactions, things like digital bodies, seem like an open question of how those work across platforms. And I know that
maybe something like GLTF for interaction will be pretty good to have at this point. So I don't know who will design that, but some sort of interaction will be, like, I know USDC has interaction, so somehow we need also for GLTF we need some sort of like specify some sort of interaction that we can all talk to or communicate via that.
Mm-hmm. Looks like the next question is if you were going to invest in enterprise XR right now, what platforms and devices would you personally use?
What is enterprise XR?
I think that is a sort of inherent in the question, isn't it? That we know what that is.
Right. Enterprise XR. I guess probably I would probably say the Quest at this point. It depends on the usage. You need to have something like you need to see the world. Like you can probably use Google Glass that I know they use for enterprise, or you can use the HoloLens. But if you need to, depends on the use case. I guess enterprise is a bit too broad, I think.
Right, and even the difference between the Quest headset scenarios that make sense, and then the HoloLens, enterprise options from Microsoft, they're used for radically different things. So it's definitely a sort of a generic question to ask. Those are the two that pop to my mind, but obviously there are many others.
The Quest can be used for visualizing architecture stuff, for instance, in an enterprise scale, I guess. And I guess you can also use for remotely controlling machines.
Yep.
But that's all I can think of too.
Let's see. There's a question about WebXR. Can we actually adopt WebXR if WebKit / Safari is so far behind on their implementation?
That's also like another. That's also like makes it difficult to understand, because one thing is WebXR. Like there is the AR side and there is the VR side. Sure, you wanna. For the things that you can do with AR right now in mobile, right now, like on the web, you're kind of limited right now because WebXR doesn't run on Safari iOS. But at the same time, if your use case is to show, like, you're doing like a website where you're selling chairs and you want the user to be able to visualize it, then that actually, like for instance with Model Viewer, you can actually do it works for both for Android and iOS, and the experience is the same. But if you need to have like a more custom interaction, then right now it's a little bit limited what we can do with Safari. But for VR, I think with the Quest and the desktop headsets, I think we have it's more of a matter of like creating experiences and not when like Safari is not limiting the VR use case.
Yeah. The next question is about accessibility. What do you think is sort of the best path forward in terms of adding accessibility, things like alt text and supporting screen readers and keyboard-only accessibility? Within the 3JS community, is there an effort to start to support more of that?
Oh, I thought that was in the context of VR or XR. Like, I couldn't picture. I know that with React Fiber, for instance, they are working on that. They are adding like accessibility for it. I think the only way that we can do accessibility, which is just the way that they did it, as far as I know, is basically like creating like fake DOM elements on top of the objects in WebGL. I think that's a little bit. I think that's a little bit out of scope of the 3JS on itself. Like 3JS is more the renderer. We could maybe like try to do like create a utility on top of it, or one example that shows how you can do that, like put like fake DOM elements, like invisible elements that you can that describe the scene, but it's not something that I will see as like a built-in in 3JS itself. Like it's something that will be an example that shows like if you want to do that, then you can do it. But it's mainly because it's very difficult to, how do you make like a instancing of like 10,000 stars like accessible? Like do you put like you cannot have like 10,000 dumb elements, fake elements, because they're gonna make the whole thing very slow. So it is by case in a case by case situation. But yeah, I think it should be something sitting on top of the 3JS, but not in 3JS itself.
Yeah, I think it's one of the nice things about the web is that there is a culture of accessibility built into the DOM right now. And so as we move into using additional modes, display modes, and input types and things like that, it will let us hopefully take some of the lessons we've learned over a couple of decades of accessibility within the flat web and port some of them in, whether that's DOM elements that sit on top of a WebGL scene or just completely different modes for different types of access. The web has lots of paths for that sort of thing. So I'm hopeful on that front anyway.
Yeah, I think Apple maybe was trying to actually design something along the lines of like some sort of like A-frame inside the DOM, where is part of the DOM, but I haven't seen. I wish I had seen more, more working groups like trying to design this, because yeah, like it's very difficult to do that as a on the WebGL layer. Like it's difficult to like try to combine with DOM. And if the browser could do some of that, could be useful. But then if the browser does that, then the browser is building a 3D engine inside too. So I'm not sure what's the path will be for that.
Yeah, and it seems like a lot of accessibility conversations land in the realm of having some sort of declarative scene language that is then decorated with a lot of accessibility media types, like sort of the equivalent of alt text, and that I think fits kind of a layer above 3JS itself. So it might be one of those things where there will be lots of different experiments on top of 3JS to add that sort of accessibility. That's my hope anyway.
Yeah, that would be good.
The next question is, do you think there's a risk of 3JS becoming obsolete given how fast things are changing each year with these new technologies?
Like I wish it become obsolete at some point, so I don't have to work on it anymore. But the only way for it to become obsolete is by someone doing kind of the same thing but better. So it has to be open source. It has to be open for like people to remix it and do their own versions and like tweak it. And and it had to be free. And it had to like be kind of simple to use. I mean, simple is relative. So I think in general the current setup is not that easy for all the people to try to do the same thing, because usually for this kind of products, like people need to have like an actual you need to it will be like Adobe or someone. You need to have a subscription. You have to put your email, and and I try to like get rid of all these things and just use the code, and you can use it and you can mix it and you can improve it, and so it's difficult to do something like that because they don't have anything in return. Like they don't have subscription, and they don't have that kind of money. But I hope somehow someone finds a business model that can maybe fork it and do it better, and I can retire. Or I can use it myself. Really, it will be good to be able to use it.
Right. Yeah. It seems like one of the goals of a lot of library writers is to write themselves out of a job so that they can become consumers of the library, because they made it for themselves. They needed it.
Yeah, that was the whole point. Now just I need to find like maybe an hour a week to like, all right, now I'm going to use it and do something with it, but it's difficult to do that.
Okay, it looks like we have Oren. Hello.
Hey.
Good to see you. Thank you so much. And of course, thank you, Mr. Doob. Thank you so much for coming and talking about 3JS. Yeah, we're going to hand it over to Oren, also known as DePanther, to talk about his work with the Unity WebXR exporter. So,
awesome.
Yeah.
Awesome. Cool. All right. Cheers.
Bye.
Okay. Bye there.
Take it away, Oren.
Yeah, so I'll just share the screen. And can you see the screen, the slide? Oh, okay, great. Okay, so WebXR using Unity. There's more than one way. And yeah, so hello WebXRs or WebXR creators. Is there a nickname for WebXR creators? It might not sound in my voice, but I'm super excited to talk here in WebXR Dev Summit. The WebXR creators community is really great and helpful. I got so much help and support from the WebXR Discord members, from the W3C Immersive Web team, the browser and the OpenXR implementers, and the Unity WebGL team. It's amazing, and there are so many people that are happy to help. Thank you. So yeah, as mentioned earlier, I'm Oren. I'm a software developer. In the last year and a half, working on WebXR Export, an extension for Unity WebGL, which allows developers to export to WebXR. Unity uses WebAssembly to compile C# code to the web. So what do we have today? We'll ask why to use Unity, what is currently possible supported, what is planned next, and we'll talk about some good use cases for the current state. But before we ask why Unity, WebXR exporters. As far as I know, I'm the only one that is going to talk here about using Unity for WebXR, so I'll mention now all the WebXR exporters that I know of, and later focus on WebXR export. First, WebXR export. It supports WebVR and AR, constantly getting updates based on the old Mozilla WebVR exporter. Lots of changes since then, more than 100,000 lines removed and added. In its approach, it's using what's available in WebGL, in Unity's XR plugin and packages. So the setup is some kind of similar to using XR packages of other platforms in Unity. There's simple WebXR, also supports VR and AR, also getting updates very often, more focused on supporting MRTK and XRTK, which are toolkits for XR development. And Mozilla WebXR Exporter supports only VR and was last updated almost a year ago. I guess there's no maintainer since the layoffs at Mozilla. There are also some exporters of scenes and animations to GLTF and some exporters to JavaScript-based media devices, AR libraries, but we are here to talk about WebXR. Why to use Unity? Unity's own tools, the editor, performance tools, optimizations tools, debugging tools, the editor, and even visual and node-based programming tools. Node need to write in C#. Rapid development in the editor, external tools, tools for artists, designers, lots of stuff that make life easier and a great way to prototype fast. Existing XR assets, Unity's XR interaction toolkit and AR foundation currently not supported, but there are other tools that can work in WebXR, like UI tools, locomotion tools, toolkits like MRTK, XRTK, VRTK, HPTK, and lots of TKs. Existing XR developers. There are lots of XR developers that already know Unity, and it will be more familiar for them to use Unity for WebXR. Maybe you already know Unity, and it will be easier for you to start using known environment, although you still need to learn some web development topics. And in case you already have an existing Unity project and you want to port it to WebXR, instead of rewriting it. Having said that, why to not use Unity. Build size, iteration times when testing on WebGL. Contrary to the rapid development in the editor, build times for WebGL are longer, so you might want to test more on the editor and test less in the browser. Download and loading times. Users might leave before the experience was loaded, and even after the experience was loaded, if the WebAssembly build file is too large, browser might have performance issue at the first few seconds. Although I know that Unity in the past 2 years doing lots of works behind the scene in order to improve this. And the current implementations of the exporters don't use the engine to its full potential. Unity's XR SDK in Unity 2019 and 2020 doesn't support WebGL. So optimizations that are possible in other platforms are not available on WebGL. Current state of WebXR export. As mentioned earlier, I'll focus on WebXR export. It supports the editor version of 2019.4.7 and up, and the 2020 cycle. Wasn't tested yet on 2021 cycle. Browser compatibility. This is a list of tested browsers. There are so many browsers, operating systems, and devices, but if it supports WebXR, WebXR export will probably work on it. I even saw someone on Reddit that used it on Oculus Go. Supported APIs. All the listed APIs are supported with some adjustments for Unity. There might be some minor events or variables that are not implemented yet. We have WebXR Device API, Gamepads module, it's including the haptic feedback, WebXR Augmented Reality module, the heat test module, it's currently limited to ray from the center of the view, WebXR hand input, and WebXR input profiles using WebXR input profiles loader. So some of you knows about the WebXR input profiles repository. The WebXR input profiles loader is a package that loads controllers and hands models from the repository assets. It's even loading the new generic hand model and allows WebXR exporters that supports the hands API to use it. What's next? Improvements for existing supported APIs, like adding some minor missing events or variables, more documentation. There's written documentation and even videos for the basics, but more advanced stuff is missing info. More APIs support, depth API, plane detection, light estimation, etc., etc. Optimizations, of course, Unity XR SDK support. And from time to time, I'm amused by the idea of porting WebXR export to Project Tiny. Unity's framework for lightweight experiences, but it's still in previous stages and constantly it's changing. So it will take time until I try to implement WebXR there. But if someone is doing it, I'll be happy to help. Even more next. Okay, in recent Unity 2021.2 Alpha 10, Unity added a critical missing piece for XR SDK to support WebGL. I didn't get to test it yet, and I don't know if I need updated XR SDK, but I plan to test it soon. As it's still an alpha, it will take time for release, and it will take time for WebXR to support it. But it's exciting. Also, according to Unity's roadmap, under consideration, they are thinking about adding WebXR support. I'm not working in Unity, so I don't have any idea if it will happen, but if it does, it will be a game changer. It's important to notice that while Unity doesn't officially support WebGL on mobile, in the recent year, they did lots of improvements to the general Unity WebGL platform regarding mobile support, and it seems like 2021 cycle is going to have even more improvements like updated mscripten version. For me, as long as the XR SDK supports WebGL, lots of extra web libraries that are not necessarily WebXR will be able to implement better support in Unity. Think about libraries like ARJS and hands-free.js in Unity. So we're almost at the end of the talk. good use cases for the current state. Prototyping, game jams, hackathons, student projects, all the XR experiences ports. I wouldn't recommend on using Unity for commercial WebXR experiences right now, unless you know well what you are doing and what you are getting yourself into. But it is possible. So let's see some use cases. There's inverse kinematic in WebXR by Paul Pivek. It uses existing assets like Game Creator and the Final IK. Silk Brush by Daniel Adams. You know him by the name M-Sub2, a port of Tilt Brush to WebXR. AR Drone by Sector X. It shows the heat test feature. A320 Cockpit by Playco Software, WebXR VR commercial training experience that shows the internals of A320 Cockpit. Runs on the Oculus Quest 2 browser. Digilab VR by Prefrontal Cortex uses experimental bridge by Needle Tools that will enable working with Unity's family of XR tools, including the XR Interaction Toolkit. It's a great opportunity to thank Needle Tools for their great contribution to the WebXR export package. And we are currently working on World's Demolisher, a fun arcade game that supports all the input options available in WebXR and runs on AR headsets, and AR handheld devices, currently in beta. Thank you all. I was running really fast as there were lots of things to talk about. So, questions?
Hi, Oren. Yeah, thank you so much. Right, that was a speed run. It's a good problem to have when there's a lot going on. So I really appreciate you running through it. I definitely learned some things. I know that you mentioned that you don't work in Unity, but I imagine that you have some important sort of features that you would like the Unity team to work on that would help you. What's sort of the number one feature that you would love them to implement that would make your work easier?
Yeah, the XR SDK for WebGL that I mentioned, that I saw that in the alpha of 2021, they added support for the main feature there. I still don't have the XR SDK, this version of the XR SDK. I have an older version, but we are. One of my goals in the WebXR export is to make it as much as seamless for developers to port the experiences to WebXR. So XR SDK will definitely help there.
And do you know what the state of spatial audio is coming from Unity into WebXR? Is that something that already exists or is coming soon, or how does that work?
I'm not sure because my hearing is not good, and but I did implement the audio listeners there as they should, and you can try some experiences made with Unity and see if the audio works well there, because Unity using in native the F-mode engine, but in WebGL, in web, they had to use the JavaScript APIs, so I don't know how well it supports for spatial audio.
Great. Well, it sounds like a good opportunity for people in the development community, including myself, to lend a hand to help out with that. We can sort of help each other do the parts we're good at, for sure.
I'm always happy to get some PRs.
Great. All right, we have Ada Rose Cannon. Oren, thank you so much. Obviously, this is there's a ton of Unity developers, so it's great to have this pathway into the immersive web. And so thank you so much. And I think this is actually a great lead in to Ada's session, which is about all-in-one workflows, browser-based editors and the teams that are making that happen. Ada, welcome.
Hi, thank you so much for having me. I'm just here to moderate the panel of the real experts here. Here they are. So we have Jonathan Hale, if they'd like to introduce themselves.
I'm the CEO and CTO of Wonderland Engine, a downloadable editor that produces a efficient WebAssembly-based runtime for WebXR applications.
And we have Stuart Smith.
Hi, I'm Stuart in Brooklyn, New York, working for Amazon, doing all things spatial computing.
Fantastic. And we have Will Eastcott.
Hi there. Yeah, I'm Will Eastcott. I'm the creator of an application called PlayCanvas. It's a platform for building interactive web contents. So you can use it for building things like browser games, of course, AR and VR, and playable ads and all kinds of stuff like that.
Fantastic. Well, we only have 25 minutes, so let's get started. The first question I've got here, which I really want to dig into, is what sets apart all-in-one solutions from the normal web development workflow for anyone to take?
I don't mind having a stab at that. So there's lots of great technologies out there. If you're a web developer and you want to build some XR content, there's many open source frameworks and tools. There's like a whole host of stuff that you can take. But if you do that, what you're not getting is any form of like workflow. So while you have the flexibility to construct your own workflows, which is great, it gives you lots of freedom, it can take a lot of time, and a lot of these technologies don't necessarily work seamlessly together. So these all-in-one approaches, give you a more structured entry to development for building this kind of content. But I think like one thing I would say that's pretty important though is that it's not really a case of you have to choose one or the other. It's kind of a bit of a shade of gray, because even platforms like PlayCanvas, which look like monolithic platforms, actually they're kind of broken into subtools, and the idea is that you can kind of take the parts that work best for the workflows you want to build. So yeah, but like certainly like a platform like PlayCanvas and I'm assuming like Wonderland and some of these other solutions, they give you a much more kind of structured approach.
Do either of the other two have any answers you'd like to add to that?
I feel like Will did a pretty good job of summarizing.
Fantastic. All right, next question I've got is, so what benefits do you see from having XR technologies on the web?
Oh, I love the openness of it. Sorry, I just jumped right in there.
Yeah. Go ahead.
I mean, the web, to a certain extent, is not owned by any country or company. You can argue that there's vast influence and people pushing that influence around, but it's kind of the best thing we've got right now in terms of shared responsibility and shared creation. And to build XR on top of that means we're going to have all of that benefit, the benefit of that free foundation to build on. It's not a perfect utopia, I know that, but I'm still a big believer in the web. I feel like we've tapped a lot of its potential, but not all of its potential. And I'm really excited that we get to play with that and build new things and so on and so forth.
That's really cool. Jonathan or Will?
I feel like the web basically allows you to do everything that XR allows you to do, but easily published, easily accessible, and secure, running in a sandbox, which might be interesting to big companies, right? So it's super easily distributed. I could imagine one day if we walk around with AR glasses, if there's a restaurant somewhere, you won't install their app, but you will click on their QR code to have their interactive menu, right?
Yeah, that's one of my favorite points as well. Will, do you have any favorite features?
Yeah, I mean,
abilities?
for me, I mean, I'm a big fan of the accessibility of the web, not just for the content, but also for the tools. So, Play Canvas itself as a development platform just sits on a URL and you can just build straight in the browser. But in terms of the content, certainly I think it's probably more natural, like you described, Jonathan, that you walk around a 3D world in AR and you can just kind of like dynamically stream content, and the web works best as a medium for that. But just like more generally, like if you look at, say, VR content, so in if you've got a Quest, you can either go to the store and you can download and install apps. If you want to view web-based content, WebXR content, then you do that through the Oculus browser. Now, kind of using a browser is the kind of paradigm we've become used to, where you kind of enter a URL and you load some content. But I think that's going to evolve very rapidly over the next few years, because right now, at the moment, Oculus have added like interesting content on the new tab, and you can kind of discover stuff that way. But there's going to be much more interesting and more natural ways to discover content, where you can just like seamlessly jump from one piece of content to another in a very sort of transient way. So I'm kind of looking forward to seeing how the whole kind of this whole kind of ecosystem of web content evolves over the next few years.
Fantastic. Now, not on like the now onto like the less exciting positive side. What are some of the pain points of working on WebXR you've encountered either through your users or for yourself as developers? And like, what have you kind of done to alleviate some of these issues for the users of your platforms?
Ooh, I'd say one as a developer is just the slowness of certain good ideas to mature and become widespread. Why can't we just link yet from one, totally immersive experience to another in the same way that we hyperlink, right?
I'm so sorry, that's our bad understanding.
No,
We're
it's not.
still working on it.
People pushing it forward. You're one of the heroes. You are not the villain in this story. It's so stuff like that where this is going to be so useful, and it's going to also just be exciting, not for just the consumers, but for developers to be able to say, I want to land at this coordinate, or I want to take someone visiting my site and land at this coordinate in your site. And then for your site to handle the whole, that space is actually restricted to logged in users, but we could land you over here, or, whatever the paradigm is. Wanted it for a few years.
so like really deep linking into your XR experience and proper parsing URL. I like that a lot, and that should be very doable.
Yeah.
Because it's just normal URL stuff the web's been doing already.
Absolutely.
Will or Jonathan, do you have any like pain points you've encountered or?
Yeah, I mean, there's a few. I mean, I'd say probably one of the main ones that I hear is problems around getting XR experiences to scale across like lots of different device types. So especially like, if you're building a VR experience, then, you want that to be able to scale from a high-end headset all the way down to maybe just a low-end mobile device. And, like I normally talk about this in terms of responsive VR. So, as like a company dealing in sort of web technologies, we sort of are always talking about responsive websites or web design. And the same principles kind of apply to building XR content. So to help our users solve these problems, we try to kind of like include lots of pre-built templates, scripts, prefabs, for want of a better word, that enable people to just like place viewpoints into their scene that automatically scale from like a VR viewpoint down to like, let's say, a mouse and keyboard controlled viewpoint, or maybe even a touch controlled viewpoint, so that setting all of that up in your application is completely trivial. And like it just like almost magically allows your application to scale across all of these devices.
So previously, before I went into Wonderland Engine, I co-founded a company called WhiteRabbit, which did XR or WebXR agency work, and also launched Construct Arcade, the free VR browser games platform that also like is recommended by the Oculus browser, for example, on like a number of games. With maybe Barista Express might be a game that people know or something like that. And what we figured is like the three biggest problems were just generally performance. I think the web has this myth around it that it cannot do high-end web graphics, which I think a number of apps and also engines have disproven, but still the myth is still around there because, oh my God, we can only have 100 draw calls or something like that. I think that's generally not true. But Wonderland Engine, for example, of course, tries to optimize the hell out of that, so to make sure that the users can spend their time, the development time, on their actual application and not optimizing their content. And content is the next part, where 3D content is larger than just an image or something like that. Often you have 3D models with multiple textures on it, especially when you go for a PBR workflow. And all that content needs to be handled in a way that it downloads quickly anyway, right? And what is also a difference to like the web-based approach is that with our all-in-one workflow kind of approach, these applications can actually handle the optimization way long before the content reaches the client side. So we can like spend loads of time just optimizing content, crunching down those bits and stuff just to like make it download really, really quickly and just render it really, really fast. And the final thing is workflow. I think there's a lot of like native tools out there currently, and they have a certain workflow established that, like coming back from my days from like native computer graphics development, where it's way slower than the web. And WebXR is just amazing for this because people have this web expectation of they change a line of code and it immediately changes the result in the browser running on the other screen, right? And we try to, with Wonderland Engine, obviously also make sure that this workflow keeps, like this mindset stays alive with WebXR also.
Cool. Thank you so much. Those were all amazing answers. And it was really good to hear all the stuff you were thinking about. What are some of the features you've heard developers asking for WebXR? Like, what do they really want to see in the platform?
For WebXR as the API?
Yeah, like, are any features where developers are just like, oh, we really want to work with WebXR, but we can't until it supports X feature?
I mean, one area that we get asked quite regularly about is like really good profiling tools, because achieving good performance is really, really critical. Achieving it like a high and stable frame rate. And I think the profiling tools available for VR platforms right now are a little bit lacking, and actually just generally in the browser, they're not great either. If you're building like a native console title or something, you've got very advanced profiling tools that give you very accurate data, and we don't really have that in browsers, or like nothing that is easily accessible to developers. So I think the browser vendors probably need to do more work in that area, and there's probably an opportunity for third parties to build better tools.
That's great.
I think for VR specifically, it might be monetization options. Just like paying through the VR headset, for example, is very, very difficult. Other than that, lots of people want to build multi-user experiences just because of the social aspect of VR. So that is something people seem to be looking for a lot.
Yeah, it'll be really cool if we can get the web payments API working in WebXR.
In the Oculus browser would be amazing.
That would be amazing, yeah. Stuart?
I mean, it'd be nice for. I know updates to WebKit are coming, but I think we all hit some pain points when developing things for iOS, which is a shame because I think we all enjoy that platform as well. I think iOS and Android are both fantastic. It would be nice to see, just in general, I'm not speaking about any specific feature, but just in general to see a bigger embrace of the WebXR community within WebKit.
It did make me extremely excited when WebXR had appeared with in development next to it on the WebKit features data. So hopefully it's not gonna be too long, I hope. So WebXR can support augmented reality and virtual reality with a single build. For your platforms, do you focus on a single one of these areas, or do you encourage developers to build both AR and VR with the same experience?
Well, I mean, with Play Canvas, we don't. I mean, each developer has their own goals, and what we tend to find is that it's pretty rare that a developer wants to build an application that has both AR and VR support built into it. So instead, like, I typically tend to target one or the other, right? So yeah, but I mean, we view both as being important to but both are important to in our roadmap, and actually, like, the speed at which the WebXR spec is evolving, it's actually like kind of difficult to keep up with the development. I mean, it's crazy how quickly like new features are being developed. So for companies and teams that are building these platforms, like just keeping up with the new features being released is a significant challenge.
Yeah, I just had to redo my hand tracking shim yesterday due to changes in how hand tracking works in the hand tracking API. They were good changes, and I'm excited to see them. But yeah, there's a lot to keep up with.
Yeah, we're definitely in this phase at the moment, aren't we? Where there's a lot of kind of experimentation and iteration going on, and the people who are building these kind of frameworks and libraries and platforms, they're kind of they're part of that iterative loop, and it's a really important process to go through, because I think like it's heading in the right direction. I think a lot of really good decisions being made. So yeah, it's all part of the process.
Sir, you might want to plug the library you were talking about.
Oh, handy.js. You can look for it on GitHub. It's open source. It just makes defining and detecting hand poses, custom hand poses, really easy. It felt like a thing that should have been easy already, but I guess it's such early days that you just have to build it yourself.
Do you think that's something the platform itself should provide, like that higher level access to hand poses?
Yeah, that's a good question. And for a second there, I thought I had a firm answer for it, but I don't. In the same way that something like 3JS is apart from the browser itself, and that is a very hefty piece of machinery, right? And I'm talking about something that's actually really small and just sits on top of 3 and on top of all of Oculus's hand tracking magic that it does. So yeah, maybe it's not appropriate for that to be in the browser just yet. But I was surprised that, it didn't exist yet.
Yeah.
It just seems like as soon as you have hand tracking, you want to be able to recognize all sorts of things that you're doing. And if anyone wants to jump in, right now it detects poses, static poses of your hands, including the ASL signing alphabet for finger spelling.
Wow.
But what it doesn't do is gesture. It doesn't relate what your hand is doing to your body, and it doesn't relate different shapes over time or different poses over time. And I sort of have an idea about how I might do it, but I bet someone watching this has a better idea and would like to jump in and contribute. So that would be awesome. That would make me
Very cool.
I have one last question before we jump to audience questions. I mean, if you don't get any audience questions, that's fine. I have lots of other questions. Yeah, one last thing I want to ask is, are there any particular projects that people have built with your frameworks that you really want to shine a light on and for people to check out and try out?
Yeah, I can. Let's see. Well, I think one of the Play Canvas developers who's really doing some exciting things right now is a company called Visionaries 777. and they are a digital agency that does a lot of work with e-commerce. So they build 3D configurators and like product visualizations. So yeah, if you go to Visionary's 777 website, they've got like one of their applications is called Cyber City. It's like it's kind of like a 80s retro style kind of neon city that you can drive around, and you can jump into like AR experiences. It's pretty cool. So that's probably what
Wow, I like that. That's cool.
So if you have a quest, definitely check out Archery Training by White Rabbit on Construct Arcade. Then if you want to watch Wonderland Engine WebXR development, twice a week, Source Code, Tim Ikoka streams development of basically a Stardew-inspired farming game. And finally, Yinky from Playco is doing a lot of interesting work of like multi-user experiences, even like cross AR and VR. So maybe find him on Twitter or something like that. Playco, really, really cool. And Ilya People is laying a lot of groundwork currently for interaction and like just things that you'll need basically in every project. So definitely check out what he's doing there too.
Well, fantastic. Stuart?
Well, I was just thinking that a lot of the stuff that I've been facilitating over the past maybe 2 years is mostly internal projects for other companies. So there's been some interesting stuff that I've been involved in, but not things that I can really share or point to for those reasons.
I feel this. I often get my hands tied behind NDAs of seeing really cool things and then not being able to talk about it. Especially as an advocate, that's a really hard thing. Someone shows you something amazing and you're just like, I want to tell the world and I'm not allowed. Cool, so we have like 4 minutes left and I was hoping we'd have some audience questions maybe.
Indeed, yes. Thank you, Ada and Will and Jonathan and Stu. Thank you so much. We have Julie Smithson, and she is running our Slido. So I will pass it over to Julie.
Yeah, we've got some great questions coming in. So many of them. There's about 8 to 10 of them. But the first one I've got that came in said, how compatible is each one of your respective engines with the JS ecosystem at large? And can I assume seamless work with Node modules for RealSense integration, Google Cloud STT, Ultraleap, Looking Glass? Over to you guys.
We use JavaScript. We have a JavaScript API. You can use any library that runs in the browser there. We even have Node support coming up, so you can actually build with Node all your projects, and you can profit from the entire Node.js ecosystem there.
Cool, yeah. In terms of Play Canvas, it's a super flexible and open system. So you can either just use playcanvas.js, which is, I mean, it's like the equivalent of, say, Babylon.js and 3.js. It's just like the framework, just the runtime. And with that, you can use it as a module or an ES5 build. You can use it with TypeScript. It's got TypeScript definitions. But if you opt to use the editor, the online platform, then you can just drop any JS framework into the editor, say like jQuery or anything like that, and call its functions. So yeah, like we try to make it as open as flexible as possible. And in terms of like supporting all of these different devices, I mean, if they're supported by WebXR, then they're supported by Play Canvas.
Yeah, that's the cool thing about all of this working in JavaScript and in a browser context. I like to say that if you're a web developer, you're already a WebXR developer. You just might not know it yet.
Right.
Great. We have some other questions, which I think you've kind of covered already as far as all-in-one workflows that you use. Somebody's asking about the barriers for entry for flat web developers to adopt 3D web into their existing content offerings.
Models.
Who would like to take that one?
Well, I guess I blurted it out. Generating 3D content or editing 3D content that you can already find elsewhere for free or for purchase. There's a lot of overhead there. That's a whole skill set that if you are purely a flat web developer, you probably don't have. You can start to ramp up on it especially with free tools like Blender or something like that, where you can really start to play around without having to fork over your life savings. So Sorry, I apologize for the motorcycle parade outside. Yeah, that's Well, I'll
yeah, I mean,
else
it's
jump in.
kind of like making a video game, right? Like, it's rarely just one individual making a video game. It's not that that's impossible, because you do find individuals that have all of these different skills. But today, I mean, yeah, if you're going to build anything 3D, and especially anything 3D, delivered through AR and VR, you're going to need all of these skills covering art and design and likely developing with the whole web stack. And it's tough to find individuals who have all of those skills. And I think like what I'm noticing is that I'm seeing this kind of like new category of digital studio spring up that specializes in building this category of content. And you find like some of the bigger digital agencies go to some of these like smaller ones to kind of like engage them to fill the gaps in their skill sets.
In case you want to start just like really small and like integrate some 3D into your existing 2D content, you can just like grab some models from Sketchfab and like use Model Viewer or the Sketchfab viewer to display them. Maybe even A-Frame could be the next step, then going into 3GS, or maybe Wonderland Engine Play Canvas, something like that. But like you can probably start small and use Model Viewer, for example, for something really simple, non-interactive.
Yeah, it's a great way to learn. I think when it comes to kind of building something in production, though, it's quite unlikely you'll find exactly the artwork that you need on a site like Sketchfab, and it's then that you kind of need to find somebody who has the skills to kind of build something custom for you, and that can be tricky, as Stuart was saying.
I'm hoping we'll start to see a new cottage industry around 3D asset production. Just like we have, there's a large amount of Illustrator communities that will produce you 2D assets. I'm hoping we'll start to see a similar industry come up around 3D assets. I really hope.
Yeah, or even just like, like more accessible tooling for building 3D content, because at the moment, developers tend to fall back on 3D Studio Max, Maya, or Blender, and all of those applications are they're pretty hard to get to grips with, right? So like if people can build like web-based, accessible, easy to use, like 3D modeling applications that anybody can get into, I think that'd be great.
I think a lot of people are building, like especially if they're working in retail, like want to build stuff so they can view products. So I think accessible 3D scanners, say at like maker spaces and stuff like that, would really help a lot of people take their products, 3D scan it, and use something even basic like Model Viewer to display it on their website would be a good start for many people.
I also think that tools in VR will be really, really useful. If you can edit the model in VR with your hands, pushing and pulling on different nodes, and you have a little floating panel that you can carry with you to, do things like, I want to zoom in to sub-millimeter level and really, fix this detail or whatever. That is so much more intuitive than having to learn how to navigate a virtual 3D interface through the 2D screen with your mouse and keyboard. So I'd love to see more tools like that. I think that would help.
That's a true visionary moment. You've already, envisioned your dashboard, what it's going to be like in that immersive space. So that's great. That's great. I know Trevor's back, and I think we're about to flip over to the next panel. Thank you all so much for joining us today on this panel and contributing. We really appreciate all of your knowledge and sharing. There's so many questions that people have, and we're doing our best to answer everything for everybody. But thank you again from all of us for joining us at the Developer Summit today.
And thank you, Ada, for running the panel. Thank you so much.
That's right.
Thank you.
And I'll see you later, Trevor and Chris.
Okay. Yes. Hello. Right. That's all. It's like a chair meeting. Hey, everyone. Right. So now we are rolling into the session about the low-level APIs that sort of underpin the immersive web and that integrate with WebXR. WebXR is itself kind of a low-level API compared to things like the document object model or CSS, but it doesn't live alone in the browser. There are several other low-level APIs that sort of go hand in hand with it. And so that's what we're going to discuss today. And today we have 3 people who are all currently from Google, but I know that I think all of us on the panel have worked at other browser teams as well. So we have somewhat of a diverse perspective on that front. We have Quarantine, Chris, and Brandon, all from Google. And why don't we do a quick round robin and just say hello and say what you do at Google, and then we'll roll into the discussion.
Sure. So I'm Chris Wilson. I obviously work for Google. I co-chair the Immersive Web Working Group and Community Group, and I actually do a lot of kind of high-level standards work at Google for the web, and that's kind of the definition of my job more than anything, I guess.
Brandon?
So Brandon Jones. I work at Google on various browser graphics and immersive APIs. Previously worked on WebGL. Am currently a editor for the WebXR specs, and am currently working on the WebGPU implementation in Chrome.
Yeah, hi, I'm Corentin, or Quarantine as you wish. So I'm also at Google. I'm co-chair of the GPU for the web community and working groups, but it's just like the WebGPU group essentially. And at Google, I also kind of lead the implementation of WebGPU in Chrome and like with various libraries and stuff. Try to get that out ASAP. And yeah, previously I was working on WebGL and Angle, so kind of similar space.
Yeah, I think that's actually a great lead-in to what I think is the first question is, so WebGL exists today in various versions and various different browsers, and then there's this sort of common underlying implementation that some of the browsers use called Angle. Maybe Quentin, if you can talk about how WebGPU fits in with sort of the evolution from WebGL in terms of graphics that relate to XR.
Okay, so there's like multiple aspects to the question. So the first one is in terms of implementation. There's a similar model to what we have in WebGL, where there's Angle that implements the API in native, and that's used by the browser the various browsers to implement it for JavaScript. So for WebGPU, we have for Chromium we have a library called Dawn, and for Firefox there's a library called WGPU, in Rust, and it's the similar thing where they implement in native and the browser exposes that to the web. And what's cool is you can use them in native. So that what's nice with WebGPU is we're going to have more implementations than just Angle, so more diversity is good. In terms of API, there's a couple of big differences. The big one is that WebGPU is more modern for sure, but it's also designed for the web. So where WebGL is a straight uplifting of OpenGLES to the web, WebGPU is more JavaScript-y in a sense, and it looks more like it fits in the web platform, even though it's kind of weird. So these are kind of the main differences, apart from the additional features, of course.
And so, thank you. That's, I think, a great summary of the sort of the place that WebGPU fits and the graphics aspect of how it fits into XR. But I think one of the things that a lot of people don't understand is how things like WebGPU and WebXR and Web Audio and to some extent WebRTC, how those all fit together as low-level APIs to allow web developers to sort of sync them together to build higher-level experiences. I know, Brandon, you've done a fair amount of work of building higher-level experiences that exercise a lot of those APIs. Maybe could you talk a little bit about the relationship of them, and when developers approach it, maybe how they could think about the interrelationship of those?
Yeah, sure. I mean, all of the APIs that we're talking about here, it feels a bit weird if anybody's used to systems programming or programming directly against native GL or D3D or the audio codecs or anything like that. But they are kind of low level as far as the web is concerned, in that it's not like you don't go to these APIs and say merely, all right, just throw up a couple of triangles over here and then play this sound and then we're good. Like they are designed to give you a lot of control over what's happening, and that control is often very verbose. And so, really we expect that a lot of times people will be utilizing them through higher level libraries, such as 3JS or A-Frame. I gotta rep the shirt from
Nice.
DAO. Yeah, like there's a philosophy behind these APIs, though, that what we want to produce is not so much like the easy to use thing that satisfies, the 80th percentile of what people want to use, because you can do that. You can target and say, well, we think that most everybody wants to do, say, 360 video with WebXR, and some of the stats that we have actually prove that to be true. There's a lot of people who just want to watch 360 video on a cardboard headset, and we could build APIs that target specifically that set of use cases. But that's not going to be what works best for everybody. And so we build these lower level APIs with the idea that they will be very composable and very flexible to satisfy what most people need. And we do have to make some concessions for the fact that we are on the web. We're in a very privacy centric environment. We're in a sandboxed environment. Like there are some hurdles that we have to get over with that. But we're really trying to build something that people can come and piece together those building blocks in the way that suits their needs specifically, and ideally build higher level, more targeted API, more targeted libraries on top of them to serve the average people's needs, such as a 360 video player or a chat app or something like that.
Great, thank you. And Chris, I know you work on a lot of different standards, and you work pretty heavily in the incubation of new ideas for the web itself. How do you think about the relationship between higher level APIs like the DOM APIs or CSS versus what Brandon was talking about with these lower level but highly composable sort of fine control APIs like WebXR and WebGPU? How, from a web perspective, a web standards perspective, how do those things fit together, and how do you decide as a in the community on which way to go with these things?
So a number of years ago, there was this manifesto that was signed, the Extensible Web Manifesto. And the Extensible Web basically said, do proper architectural layering in the web. And there's a lot of subtleties to this, but it basically is like, think down what kind of bedrock APIs you're trying to expose to people and give them access to. And then don't build just the top level infrastructure, like the top level, easiest HTML tag level thing to ship, because they're going to want access to those lower levels of capability too. And that's why we've gone through and built things like, WebGL and WebGPU, where you get very low level access. It's really fundamentally what the WebXR API itself is. It's not defining virtual worlds, it's getting access to the hardware and being able to build it into a system that provides these virtual worlds. And that means for things like web audio is a great example, where it actually does have some higher level semantics built into it, but it gives you low level access to the audio hardware also. And because it's defined at a relatively low level, it's not just play back this sound file like we used to have with the audio tag. It can provide things that let you set up and combine with some of the other APIs. And then you get frameworks or implementations that build and use all of these together, like 3JS, for example. It builds on top of WebGL. It builds on top of WebXR if you're doing a VR scenario. And it uses web audio, which has a built-in 3D positioning panner and uses all these to provide a very convincing 3D positioning of sound in a VR scenario. And as a user, this is actually quite easy to build, like quite easy to set up and attach a sound to a particular position in space. Now, there are some subtleties that come in and some challenges that come in when really low-level things can be very, very powerful, and we have to be very careful about how they get exposed. We don't want to provide tons of fingerprinting surface area accidentally, or we don't want to, enable security problems by giving direct access to some bits. So there are some places where we provide higher level semantics as well. But I think the challenge is really looking through the use cases and scenarios. And this is something for incubation purposes we've gotten better and better at in the web, probably over the last decade or so, really thinking through, well, what user use cases are we really trying to provide here? What do developers want to do? And how can we expose it in the right set of ways?
Great. Yeah, that balance, working in the WebXR community, I know that balance is definitely tricky. And one of the aspects that I thought was really interesting that I think all three of you would be able to speak to is how, as we move to these lower level APIs and we make them more and more capable for reasons of performance or flexibility and modularity, how do we avoid violating one of the core tenets of what browsers promise users, which is that they won't be uniquely identifiable? We call it fingerprinting a lot of the times, but I know that one of the things I hear from a lot of developers is they want to know what GPU, they want to know the name of the GPU it is that they're addressing, and they want to know, sort of all these really specific details about the hardware so that they can more accurately target their experiences to them. How do you think about addressing, balancing that need to be able to have performant and device-specific capabilities versus letting users trust that when they go to a website, they won't, as much as possible, will prevent them from being uniquely identified as individuals?
I guess I can maybe start on and then I think I'll then Chris can follow up probably. But so it's true for like flexibility or just being able to choose the most optimized code path in various places. You want to know what you're running on. Something that we're discussing at the moment in the WebGPU group is, for example, your machine might be capable of WebGL2, but not capable of WebGPU. And in this case, we might provide you with a software implementation of WebGPU just so you can test things. But you as a developer want to know if you're running on software, if you can also run on WebGL, because then the best experience will be on WebGL instead of WebGPU for that particular machine. And so to do that, the question is, how do you expose this information in the APIs so the developer can make the base choice? And that's one bit of fingerprinting, for example, for is my WebGPU adapter software or not? And so there's a lot of discussion around this, and the kind of the difficulty we're in right now, like as the web API folks in general, is that we browsers are collectively figuring out what the privacy story of the web should be, and there's multiple approaches being discussed. And so that's where Chris can talk more about. But I think because we're in this kind of middle ground state where we don't really know what the exact story for the web is going to be, I think it's important that API is designed so that the browser is in control of what it exposes. So for example, we may have a name for the GPU you're using in WebGPU, but there will be provisions in the spec to say that browsers are allowed to fake the name. And if they fake it, then they probably should use this name so that it all seems like the same. Just this type of thing so that the browser is in control and can choose depending on the context. If you're in an iframe, I can add iframe, for example, maybe you don't get as much power, things like that. But put this flexibility in the spec at the moment so that as the privacy story for the web crystallizes, the browsers can make the right choices. But I'm sure Chris has more to say about that.
I don't know, that covered it pretty well, I think.
Okay.
So I'll speak a little bit to like WebXR API specifically in this realm, because this is something that is, the hardware that we're talking about has the potential to be very, very personally identifiable. And this is coming from things like, if I've got a headset on, like there's going to be a whole bunch of micro movements of my head that are moving around that like I can generate or hand information. Like we do have hand tracking in some modules. And this is fingerprinting in a very literal sense. I'm getting like a structure. Yeah, I know. I'm getting the structure of your hands and everything like that. And that's going to be fairly unique to you. And there's a natural tension between saying, well, we can't just smooth over some of this data. Like if you're taking your head motion and trying to smooth away the identifiable information, you're probably going to make people sick because you're no longer accurately representing their head motion. So how do we deal with that natural tension? And in a lot of cases, it's about structuring the APIs in such a way that you're giving the user a chance to make informed consent about using it. So what we're very concerned about with WebXR, for example, is making sure that we expose the absolute minimal amount of information until you as the user say, yes, I want to engage in an immersive experience here. I'm clicking on the button, we pop up something that says, this is what the page is about to do. Do you give consent for this origin to do that? And once you say yes, then we can unlock a whole bunch of information because you've indicated that you trust whatever whatever page you're interacting with to handle that responsibly. Now, like, this isn't a perfect system. Sometimes there will be pages that you feel like you should be able to trust and they're trying to do something nefarious. But what it does prevent is you're not going to go to some random web page and they're going to be able to do what we call drive-by fingerprinting, where they can just say, well, I'm going to poke at all these APIs while you're reading an article and generate this perfect profile of you from your XR hardware that you just happen to be wearing while you're looking at, say, the in-browser view of the page or something like that. That's absolutely not what we want. We want you to make sure that you are aware at all times when your browser is using that hardware, just like browsers are very good about surfacing when your camera is being used or when your microphone is being used, because that is a similar level of sensitivity of the data.
Yeah, that's a really good point. I mean, we had a lot of similar issues even with web audio, where it's very easy to accidentally expose functionality to the point where this is why we have autoplay limitations, where we won't automatically allow people to play audio. It's not just a user distraction. It's also, you can play ultrasonic beacons and somebody else might be able to pick them up or do things like that. And we have to fundamentally, like, if you have access to microphone, you have to understand that that's a very powerful thing, and that you may not even hear things that people can pick up, right? You can hear ultrasonic beacons. They're actually a really useful thing in some cases. And because of the way audio works, just like what you were mentioning with small head motions and things like that, you can't actually smooth them out without really damaging some of the core scenarios. And this is a fundamental concept of, we have to inform users and make it so that information isn't too noisy, right? That users actually get it and understand what they're enabling access to.
Do you see a lot of room for different browsers to choose different levels of access or user interactions for these sorts of privacy, or sort of not just fingerprinting, but also, like you were saying, access to audio? Is this something where we can look forward to having different browsers have different approaches to these entirely? Is that one of the things that you're working for?
I don't know if different approaches entirely is the right way to think of it. I do think absolutely different browsers will set the dials at different places for their users. They will have different approaches to things. I don't think anyone would ever, turn on all of the things just like without any user consent or anything like that. And I don't think anyone, like turning everything off also results in a pretty basic experience. But somewhere in the middle there, you're going to have very different scenarios. And one of the things that I've found really interesting in past history was even once we started using the web platform to do things like kiosk systems. You understand it's a totally different scenario. Like user consent doesn't mean the same thing because your user walks away every minute or so, and a new user walks up, and how do they know that, you know, they just turned on audio recording or something like that? Like these things have to be presented to users across a different set of scenarios. And it's not like we need a whole new underlying platform underneath them. We just need different ways of thinking about those permissions and different ways to expose them.
Yeah. Another example in the same vein, kind of the opposite of the kiosk scenario, is PWA. When you've installed an app to like your desktop or home screen or whatever it may be for your platform, that in a way can be treated as a certain level of consent because you're making the choice to say, I want to have this more readily available. I want it to be treated more like a native application. I probably don't want to be spammed with consent dialogues every time I open that up. And in the case of something like WebXR, we may be able to say, well, if you've installed this to your home screen, maybe we can just jump you straight into the immersive experience rather than having you click through to that button, which is so critical to the drive-by web. But when you've installed it in this particular scenario, it becomes more of a usability thing to just be able to jump straight in there. So there's a lot of things that get considered.
Hi, guys. Thanks so much for joining us. Hi. We've got some great, yeah, thank you. Thanks, Trevor. We've got some great questions coming in, and we've got a fan of Brandon's here. But the question obviously goes for all of you guys. I've got, they're coming in. I've got, I think, 9 questions now that we've got great interaction happening from our viewers. So how do you see the future of highly interactive parametric 3D models? Are there plans for things like GLTF, GLB to support instancing and tiling? And would you build these in an editor like Blender using custom codes like JavaScript or in an alternative format? Who would like to take this one on? Brandon, it's meant for you.
On the question, so I guess I better go first.
Go for it.
I'm a big fan of whoever asked this question. So, so in terms of things like models like GLTF and GLB, one of the things that we get asked a lot is like, why can't I just have a model tag? And like, there would be certain benefits to that, but in many cases, anytime we discuss it, it actually ends up feeling more like it's more beneficial to allow these composable low-level APIs that we've been talking about to pick up the slack and actually handle some of the heavy lifting for that. So a really good example of how this works out in kind of an ideal scenario is that we have the model viewer tag that was built by a team at Google, and you can go and you know, link to that resource from your page and just put a single tag in pointing at a GLTF file, and then it does this nice little embedded viewer. And the cool thing about that is that can keep evolving at a very rapid pace because it's a single user space library, not a standard. Standards move slow, in case y'all didn't know. We try our best, but they are slow moving, and they tend to play catch up with some of the more proprietary APIs. But if you have a user space library, then it can catch up really quickly with all of the new bells and whistles that come out of something like GLTF, which is a constantly evolving format. It does get things like instancing and tiling as extensions. It's gotten compressed textures. It's gotten new material formats. It's got all these different things that go into it. And so a lot of times those type of uses we do see best as building on top of these low-level facilities that we've built. And in terms of building them, like it's really like building those assets. It's really up to whatever you as a user are comfortable using, especially with standardized formats like GLTF. They're getting to the point where you can export them from just about anything.
Amazing. All right. The next one is, will WebGPU disrupt WebGL-based engines, or is there a slower incremental migration possible? I don't think anything's slow these days, but who's got an answer for that one?
I could take this one. So
Sure.
Thank you for the question. So in a sense, it depends what you mean by disrupt. WebGPU is a completely different API compared to WebGL. So there is some amount of rewriting that is necessary to port an engine to WebGPU. We tried to add things like compute shaders to WebGL, but it was extremely difficult, so we abandoned that effort in favor of WebGPU. But in an engine, there's a lot of things that are not specific to one graphics API. A lot of the algorithms, a lot of the model loading, a lot of the scene graph, all of that is not dependent on the graphics API. And so we already see frameworks like, so Babylon.js is almost completely ported to WebGPU, and it's some effort, but it's not rewriting the whole thing. And 3.js is also porting at the moment, and it looks like it's not an insane effort either. So there's no incremental migration possible, but it's not like rewriting your whole engine either. It's just the graphics part.
Great. Okay, let's get through some of the questions keep coming in. So let's try and answer them. From Google's perspective, what are the plans for desktop WebXR and Chromium in comparison to mobile, between cool Android WebAR features and Oculus's phenomenal work in the browser? Feels like desktop WebXR is a bit on the back burner in comparison. Who would like to take that one?
I'll take this one really quick. So first off, full marks to Oculus for their truly phenomenal work on their browser. It's a great environment to work in. And we do see that a lot of just general WebXR use comes from Oculus platforms. Similarly, like AR tends to be the thing that most people interact with on mobile devices outside of like the 360 videos scenario that I explained earlier. And desktop, it tends to be a smaller slice of that pie. And as a result, it gets a little bit less attention proportionally, because there's just not as many people using using XR devices in that environment. We are still working on it. And in fact, I want to give a huge shout out to the team at Microsoft, because they've been doing a bunch of excellent work in Chromium in conjunction with the team at Google to move the OpenXR backend for our WebXR API forward. And they're doing that in order to target the Windows Mixed Reality platform as well as HoloLens. So there is continuing efforts happening in that space. They're probably just not as visible because that tends to be one of the lower usage scenarios.
All right, I think we might have covered some of these. Is there anything that we didn't cover? Our non-Chromium browsers, I think we just talked about, did we just talk about that?
Yes, they are.
Yeah, and WebGPU. Let's see what else. What resources would you recommend to learn more? That's a good one, because I always think, what would you like to share with somebody else? And we're coming up to the top of the hour. So, maybe each of you could share some of your tools that you would advise other people to pick up and learn. What would be in your toolkit to suggest others to do the same?
So for WebGPU, we don't have a lot of content yet because the API was still in flux, so people don't necessarily want to take the time to update things all the time. But we have some kind of a landing page at webgpu.io where there's the implementation status of various browsers, and at the bottom there's a bunch of links to samples and demos and some articles. And I think we'll just take a look at that page and update it, because webgpu.io is a super easy to remember URL, so we should just update that page. We'll take a look after this.
Yeah, on the WebXR side, I would say there's the WebXR samples page that you can look for to get an idea of how the low-level API works. But honestly, if you're just getting started in this space and you just want to throw cool things up on screen, I'd suggest looking at things like 3JS, Babylon, A-Frame, PlayCanvas, some of these better known libraries, because they have a wealth of tutorials that go along with them, and they have these APIs implemented kind of at their core, so they can do really good things with them.
Awesome. I think one of the last ones, well, it says, will Chrome and Google get same origin WebXR navigation like the Quest? Do you think?
That is probably not going to happen, at least with desktop Chrome right now, because one of the big advantages that Quest has is that they have an in-VR browser, and we just don't at the moment. And that makes it much easier to surface this kind of information about kind of seamlessly going between origins. So that's just one of the advantages that they have that we're not able to match right now, and it tends to make it harder to do features like this.
Okay, all right. Well, I think we're at the top of the hour, and on behalf of all of us at the WebXR Developer Summit team, thank you so much for joining all of us in this panel today. Right, Trevor?
Thank you.
Thank you. It was great.
Thank you.
Yeah.
The low
Thank you
level
so much.
part of the story is an extremely important part of this story. So I appreciate you all three coming in and helping tell it.
Awesome.
Yeah, so I think we have a break coming up. So until 15 after the hour.
Yeah.
And so that'll
And we
give
have a great afternoon. Like, hopefully nobody goes anywhere. We put this break in there to get a coffee refresh, a bio break. And when we come back, we've got Metaverse. My company is actually presenting our CTO, so you'll be able to take a look at that. The W3C committee. Chris, you're back on stage in a little bit. Yes, you're back. And we have Trevor is also doing another presentation with us. And then we have React XR. We've got some more on performance and optimization and universal AR. So we have a packed day ahead of us. This is only the beginning. So make sure you take that break, but come back right away, and we'll be ready to start off in the next 15 minutes. So wherever you are in the world, we'd love to find out where everybody is in the world. So maybe we'll throw up a Slido screen. The team can, in the background, throw something up, and we'll find out where everybody's located. It'd be interesting to see, because we have watch parties going on everywhere, and it's really great to see so many people tuned in to learn about WebXR. All right. So we'll call it there for the next 15 minutes. We're just going to go on a break. Thank you so much to our panelists.
Thank you.
Okay.
It's me. Hello.
Hello, everybody. We are about to return with Waleed Abdelati from Meta-Multiverse. First, we wanted to thank our sponsors, FutureWay, with open source ecosystem development and ecosystem development. I'll fix that card next time. And engaging in WebXR open source. They're doing extremely important work, and most importantly, they want you to know that they are looking to support the building of amazing experiences. So please reach out to Daniel Ljunggren and Mats Ljunggren of FutureWay. And we would also like to thank MetaPrime, Extended Collection, and the Immersive Wire, along with our other sponsors, which we will be back with soon. And we will be starting in just a moment. So everybody get into your seats. And first we are going to bring Trevor Flowers back on, and my controls are.
Hello. Hey, everybody. Yes, welcome back. We are just about to fire up the next group of sessions for the WebXR Developer Summit. I hope you had a good break. Next on the ticket is Waleed from Meta-Multiverse. And hello, welcome.
Hi.
And Waleed, I will leave it to you. Take it away.
All right. Hi, everybody. My name is Waleed Abdelati, and I'm the Chief Technology Officer at Meta-Multiverse. Today, I'm very excited to discuss a little bit about the Meta-Multiverse engine and how we utilize the WebXR hit test. But before I start, I would like to thank the organizers, the sponsors, the volunteers, and everybody involved in making this conference happen. All right, let's get into the editor. So the Meta-Multiverse platform is a no-code, low-code, drag-and-drop system to easily curate and publish 3D experiences. I'll be touching on some of these topics, as well as diving into the more code scenario for all the devs out there. So let me create a new WebXR template. Now, our platform looks familiar. You've probably seen this in a style like Unity or other applications. We've got our scene, our assets, our inspector, and this template out of the box comes with a few built-in stuff, which is really cool. We have our AR marker. We have a button that will engage the marker. We have some configurations when it's on and off. And out of the box, anything you put into this project will work in WebXR. Let me put something in here quickly just so you can see what it looks like when you add objects in here. Let me make this a little thinner. By default, our system works with PBR. So we have an actual PBR skybox in here. If you wanted to see how that looks, every item in here by default has the ability for PBR. So you can mess with that. Let me add a video in here. Let's just make this a little nicer. Let's add our favorite bunny, Big Buck Bunny. Let's make sure this guy's working. Great. Now let's add this video to this mesh. Put them into the albedo. Let's make sure everything's still working. And let's publish. And that's it. WebXR works right out of the box like that. It is magic. No, it's not magic. It's APIs. Let's look a little bit underneath the hood on how this works. So as I was saying, we do WebXR out of the box, but obviously when we're saying no code, low code, there is code. And the way we actually do the code is very straightforward. We've got a world controller that is connected as the central point in the system. So if you were to go into the JavaScript folder that comes right with this template, you'll see that we have a few controllers that are engaged. Our world controller is our entry point. So before I get into what we've organized here, you have access to our entire pipeline. We've got some custom props here, but what comes default are your initialization, the render pipelines, the mouse events, scroll events, touch events, surface events, all sorts of pipeline access. So what you can do in here is that you can override it. And this is exactly what we did to get WebXR working. So off the bat, what we've done is we've organized the WebXR session, the reference space, the viewer space, the hit test source, and we always want to make sure that XR is supported. So the first thing we do is we detect, is XR supported? And then when the session started, we add in our GL layers, our hit test source, and then this is how we actually run our animation frames. One of the key things for us is that we like to have our system developed in both VR and AR. So this will work for both VR and AR. It's not exclusively VR. It's not exclusively AR or XR. Now, how does this all work? Well, when that button that I showed earlier is engaged, it actually calls a function in here that changes our state from main to AR. And then when the render pipeline comes involved, go down to it, our render pipeline, we block out everything. So we actually hijack our renderer and we let the XR session run. Well, how does that work? Well, once you're engaged, once you toggle the WebXR, the first thing we do is we request the session or we end it, and we're using the hit test and our canvas as our overlay. Once that is connected, the XR frame session starts to run. Now, what are these web APIs that we're connected to? Well, the web APIs, the WebXR APIs that we're connected to allow us to actually get the camera information, and our system works directly with it. So as the frames are running, we take directly from the camera the projection matrix and stick it into our camera. Then we determine to see if there's any hit results, and if there are, we capture it. However, when we first engage the XR session, there is no AR anchor, so we have to go through a bit of instructions. So we have to hide everything in the scene. We show the instructions, and we hide the marker as well. And as it's looping and as you're looking for a plane on the hit test, you'll eventually get an anchor. When the anchor is captured, we then move you to the next step, which is to show the marker. So we hide the instructions, we show the marker, and we hide everything else. And then when you tap the screen, we choose that marker, and then we show everything else in the scene. Now, when we say low code, we mean low code because you don't really need to do anything out of the box, but what we have is access directly to our render session, to the WebXR APIs. You can do anything you would like. Now, one of the interesting things about this is that you can easily integrate any other APIs in here because we are running everything in JavaScript. So let me do one more interesting import. Let's put in somebody to actually watch this video, this big bucket. Let's put this robot in here. All right, let's get this robot out of the way. Let's just let this get upload. Let's open up this robot. Let's drag the robot in. Let's move some things around here. Let's get this guy up. What I'm going to show you guys here is that because we do PBR directly, we can use PBR maps directly. So in here, you can see that we've got access to all the standard PBR pipelines out of the box. You don't need to worry about how it's connected. You don't need to code anything. However, you do have access to doing your own code, as I was showing you. So the world controller gives you the ability to do that. And then the object controllers give you the ability to connect these pieces. Let's get the silencer in here. Roughness, data. Let's get the R channel for the opacity map. All right, we got ourselves a robot. This robot can be watching this screen. There we go. And let me publish this. And there you go. Our system is already updated with the new robot and works directly in WebXR. If you would like to take a ride with this, I'll leave this on for a few more seconds. But this is generally how we like to handle our projects. You've got the 3D environment that you can easily manipulate items into, organize your scene, and then if you would like, you can go ahead and add more control by programming in JavaScript using any APIs you'd like. We do have some helpers that we've added into the project, but as you can see, WebXR plugs directly into our system. So any other type of API for the WebXR system can be attached to our system. So go ahead, go to engine.metaverse.com, register for a free account, and start using the WebXR template and show us what you can do. Thank you, everybody.
Great. Thank you so much. Yeah, I love seeing the fact that all of the sort of low-level work on all these APIs and all of the maturation of the 2D web, and libraries like React and sort of our capabilities as a whole have come to a point where we can build these rich, full-featured editors where people can create these experiences without a lot of code. You mentioned, that people may have seen this sort of editing in native applications before. What were some of the inspirations specifically for the UI and the developer workflows that you use to put this together?
Well, some of the bigger players in the market, like a Unity or an Unreal, they've obviously established design flows for a very long time. So we didn't want to break from that too much, but what our main goal was to be on the web. So one of the ideas was, how do we get such a mature product working on the web the way people are expecting it to work? So we stuck with the standard flow of where things are and the standard scene graph concepts. And what we did was we wanted to make it as easy as possible. So when we say no code, low code, we mean that because we've got the ability to have it very visually pleasing, and you can set up a scene, have scene decision trees. We've actually got a really cool part of our system, which is configurations out of the box. We can visualize the decision trees and things like that. But as you can see, things that we don't normally present is the actual amount of code that goes into the system. There's plenty of code. So if you are a developer, you can override everything. You can redo everything. You can mess with the GL layer. You can do whatever you would like. We obviously don't recommend that if you want stability, but sure. you have the ability to. So a lot of people get scared from, oh, no code, low code, we're stuck. We're stuck with a system that doesn't allow us to do much. No, it's no code, low code from a curation perspective. But if you would like, you can get a plugin, and the plugin can actually help augment the editor. So then, there's a piece of code, and again, this is inspiration from Unity. There's a piece of code that interacts with our inspector. So this code could do many fancy things, but from the end user on our platform, they're only sliding some little slider, right? So we're very much allowing, the full swath of code, but we've tried to keep it as simple as possible, because at the end of the day, our need for this product was to simplify the development cycle that we've been having with our customers and what we've been doing. So this is sort of what we hear from our customers. How do we simplify the process? And how do we make it so when you press publish, it updates? We're focused on making the web and 3D work together, because people make web pages, they expect you press a button, it updates. Well, why can't 3D be that way? And our platform allows you to be able to easily just go in, do what you'd like, get as advanced as you'd like, or use the simple plugins that we have, the simple visual tools, and then press publish. And that's it.
Are there things that you would ask for, sort of high-level features or functionality that is holding you back right now, that you feel like you need from either the specification community or from the browser implementers?
I've been watching all day. There's a common thread, and that common thread is, first of all, stability in the drafts, right? I feel like there are a couple of things that changed over time. Part of why we didn't immediately jump on WebXR, especially because the WebVR, it all changed, and it was dramatic, but we weren't there. We were working with it, but that started to stabilize, and then you can see that we're starting to, you know, put this as part of our platform because we know that this is going to stay stable. Now, the other challenge is you know, iOS. Now, we've managed to get iOS working, but when it comes to WebXR, as everybody has pointed out, is a bit of a challenge. And we, you know, there are companies doing things to try to utilize the single-threaded environment, but again, we know there's only so much horsepower you can pump out of the browser. So having WebXR natively available takes away from people trying to spend too much time on getting just XR working, and they can focus on the project and focus on making something immersive and not a gimmick, and actually get a lot of juice out of the browser. So yeah, it comes down to compliancy and a couple standards. Shared buffer array is a big one for me. We would love to have multi-threading across the board. OpenGL, you know, 2, 3, a little higher, but you know, WebGL is coming out. So you know, there are some things that are going to be beneficial to the community, our company, everybody in the near future. So as soon as it becomes more stable, we will flip that switch and out of the box have everybody, you know, I didn't mention, we work on every platform. So although we do WebXR, we weren't sure. So we had to make sure that our JavaScript core library, WebAssembly, JavaScript core library works natively as well. So if, you know, no need for native applications, we are more than happy.
Yeah, and that's kind of the theme of the day is right. Let's put it all in the browser and make the browser a good place for this sort of work. So thank you so much for talking to us about it. You know, I think that there's a lot of people in the audience who have never seen that kind of interaction in a browser. So thank you for sharing. So next on the docket, thank you, Waleed, obviously, but next on the docket, we have Ada and Chris, and Aishagul, I think, is scheduled too, but there's some tech problems with that. So I think right now it's just Chris and Ada. Yep. And they're going to talk about the WebXR roadmap and how the W3C is approaching these problems. So yeah, I will hand it over to the very capable hands of the co-chairs of the W3C Immersive Web Community and Working Groups.
Thanks so much.
Thank you. Yeah, I'll got some slides to share, so I will get started. Great. So normally, well, ideally, Aishagul would also be here, who is the other co-chair, but I'm Ada Rose Cannon, one of the co-chairs, and
I'm Chris Wilson.
I'm from Samsung, and Chris is from
Google.
And Aishagul is from Microsoft, who unfortunately is having technical difficulties.
But hopefully will be able to join us somewhere here.
Yeah, hopefully if I can waffle in for the first few slides, she'll like pop in by the time it's her bit. So yeah, here's like a very quick overview of like the timeline of how stuff has happened in the immersive web. So ignoring the web VR bit, because that was before the working group. The working group was formed to build WebXR and to replace WebVR, and this was in the first quarter of 2018, where we did lots and lots of work for a couple of years until Q4 2019, when WebXR started to be enabled by default in browsers. This was kind of the point where it's considered like a ready-to-go drop-in replacement for WebVR. So users of the API could change their endpoint to the WebXR one and should have all the features they need to continue. In January of 2020, WebVR was deprecated. And was considered no longer supported. So hopefully now developers, especially if you're watching this, I would have hoped you would have, if you had anything working with WebVR, I hope now you've moved it across to WebXR. And then during the middle of last year, the augmented reality features started to become more available in mostly through handset browsers on mobile devices. Hopefully, we're going to see more headset WebXR capable AR browsers soon. And as of very recently, at the beginning of this year, hand tracking became more stable and was released from not behind any flag on the Oculus Quest, which is incredibly cool. And it's been great to see people already building amazing things with this new API. And so that's kind of stuff that's happening at the moment. And WebXR has gone from strength to strength. The launch of the Quest 2 accounts for the precipitous rise around early October last year. And there was another peak around Christmas as a lot more people got those headsets. This graph is only tracking virtual reality headset use cases because it's from the CDN for the assets information, like the one that provides the controllers. So if a headset doesn't have controllers, it's probably not going to affect this graph all that much. So this isn't really accounting for handheld AR or cardboard. Speaking of cardboard devices are surprisingly still one of the most popular ways WebXR is used today. So if you are producing WebXR content, don't discount this device. It's what a lot of people are still using, and many browsers on mobile support it as one of the official WebXR like VR output formats. The majority of the content made for WebXR is 360 video content. So like the simplest thing, I know it's not like considered the most exciting field, but it is what's most popular and what people seem to be using it the most for. Also ideal for the WebXR headsets. So that's kind of cool. And I hope the people doing the 360 video content are using the new Layers API, which has started to land, because that's what is ideal for doing video content. And there is a polyfill for it in case the browser doesn't yet support it. We're also seeing increasing amounts of desktop tethered WebXR as OpenXR is as a backend for WebXR becomes more available in browsers. We're seeing it used a lot more. It's got implementations in a bunch of browsers. Unfortunately, they're all Chromium browsers right now. So Chrome, Samsung Internet, Edge, Oculus browser, off the top of my head. But hopefully soon should see it launch in WebKit, I hope, as it is in development. So that's very exciting. So I'm hoping we'll see that soon. And here are some of a few of the experiences I'd like to highlight. These three experiences all won awards at the first ever Poly Awards, which was held a few months ago. So Reaction by Tower Max Fitness is a very cool looking boxing game. What You Don't Know by Jono and Mr. Doob lets you VJ in virtual reality and control the song and the visualization in real time around you. It's very cool. And Anthropometron by Dr. Keith Chan is just a fantastic example of how VR can be used for museums, and it's a really fantastic experience. So the thing which I really want us to talk about today for WebXR is kind of the features you'll have in WebXR and some of the stuff that's landed and some of the work we've been doing as a standards body over the last few years. The first thing we're going to talk about is the stuff that's available in browsers today. And then after that, we're going to talk about some of the stuff which is a lot newer. So firstly, I want to talk about just the WebXR core. So this is where it all began. This was this covers mostly the virtual reality features. It was designed to be a replacement for WebVR, but made to be extensible and as future-proof as possible, so it can support the myriad of ways that WebXR can evolve into the future on all kinds of fancy new hardware that isn't even developed yet. The next module, which we worked on, was the augmented reality module. So this allows like WebXR scenes to correctly display the virtual content on top of either a camera feed for something like a smartphone or a headset with a pass-through camera, or on top of a transparent display for something like the HoloLens. And it tells it how to render it appropriately. Next, we have gamepad access. So you get input from the controllers via the core WebXR API, but this only gives you two buttons, the grip, like the squeeze, and the trigger, the select event. So gamepads gives you access to the associated gamepad object for each controller. So this lets you access all of the buttons and the touchpad and joysticks on the controller. So this is extremely powerful access, letting you build really bespoke experiences for if you want to support a particular piece of hardware. Next, we have hit testing, so ray casting. So this lets you cast out like a ray from your virtual controller into the real world and detect where it hits some real object and return this position. This lets you place virtual objects so that they appear to be correctly located in 3D space in augmented reality. So this isn't full environment scanning or anything like that. This is just like single point tracking in the real world from a particular location relative to the user. Next, we have DOM overlays. So currently this is the only way of getting DOM content into WebXR. And right now, the only implementations for it are on handheld augmented reality, and it places the DOM content over the virtual content as if it was placed full screen. So far, we need to work out what DOM overlays even means for head-mounted displays, or even if that's something that still makes sense. But that's something that's being actively thought about at the moment. Next, we have layers. So layers is really, really powerful. So it lets you, the current implementation lets you embed static images and video content in XR. So, and by video content, I mean like the video element. So you can use it for dynamic video content like streams and stuff like that. So if you have a WebRTC stream, you could hook it up using the Layers API. It gives fantastic performance improvements and a better user experience. So it's just great to use all around. So if you have this kind of content, Layers is probably the way to be doing it. In the future, Layers may be a way that we're going to be a way to display DOM content, but we don't even have an incubation for that yet. But it is something which we think is really important, and this may be an approach we take to do it. But it's still very early days for that yet. So right now, best for static images and video elements. Right, next we have hand input. So hand input gives you access to the hand tracking capabilities of whatever headset you're using, letting you both render the hand to the user so they can see their real hands, and also use this hand model to interact with the environment. I'm now going to hand it over to Chris Wilson, and he's going to talk about all the stuff that's currently in development and coming in the future.
Thanks, Ada. So I'm going to cover the work that's still in development. And although the first two of these actually have early implementation shipping in Chrome, these are all incubations that may not ever land. They might take a long time to do so. There are some really hard problems in some of these, particularly around enabling features with good privacy and security protections for users. So let's go to the next slide. And what we're really asking from you is to show your interest. Like if you think these are important features, dive in, read the explainers, file issues on them, try some of these things out. We do have trial implementations of some of them under flags in various browsers. So you can really help define what the future of WebXR looks like and what use cases and scenarios really need to be filled next. Note, of course, you shouldn't ship production experiences that rely on these features. You're probably going to have to revise your code before you ship it. So next slide. The first API I wanted to mention is lighting estimation. And this is really critical for augmented reality scenarios. It's really important to estimate what the real world light sources are. So when you composite virtual objects into a scene, they look like they belong in a virtual environment. We do have a trial implementation of this. There's a pointer to it, but this is super important for augmented reality scenarios, so they look more real. Next up is depth sensing, which is the first step to kind of providing believable interactions with the real world environment, giving a continuous depth map to code so you can see where how physical objects are in the actual augmented reality scene. This lets virtual objects interact with real ones. You can have objects that sit on top of tables and roll off or something like that because you know where the objects are in reality. Combined with that is the next thing, which is anchors. And anchors, it's not always immediately obvious what the point of this is, or it wasn't to me when I first started here. It's really accounting for the fact that AR systems can provide better tracking if they know what things in the real world they're trying to anchor things to. Like in this case, anchoring to that tabletop, you can give a much better, more solid visual anchor on the tabletop coming from different AR platforms than you can if you just say, hey, position this at this XYZ position in reality. It's much better to anchor to a tabletop or a spot on the wall or some other object because the system can make that more reproducible. Next is computer vision, and computer vision is a really broad topic. If you go look at the repository we have for this, there are at least 3 definitely big chunks to this, and one of them is raw camera access. Just kind of punting and saying, you know, when you're running an AR system, let's just pass things through so that people can experiment with getting access to different things, detecting different things in the scene. Then there are native shape detection APIs in many of the subsystems we use, like for recognizing QR codes or text in scenes or faces. If you're walking down the street and you see a QR code in reality, that could be an interesting thing in the future in an augmented reality scene. And then, of course, other native computer vision capabilities, doing edge detection or other object detection, estimating postures, things like that. These are kind of far out there in some cases, and they definitely have some privacy concerns since you are enabling the computer to see. But this is critical to making it so that we can actually interpret the real world live. Combined with that is real world geometry. And this is really just mapping the geometry of real world objects, giving you not just a depth map, but actually hey, there's a plane sitting at this location. There's a wall here. Maybe giving a mesh of an object so you can see things like chairs and even potentially recognize them in the future. So this is also a super deep whole topic area. And one of the more interesting long-term efforts is geographic alignment, how you can attach objects to a real world position, like a latitude and longitude and height, for doing a global, like using the real world location as your coordinate system. And there are a lot of technical challenges with this, but there's also a lot of like privacy issues and security ownership issues even, like can people just arbitrarily place things on property that you own? And how that works when you start getting to sharing those locations. And then I think finally one of the big topics, and this is something that is relevant to VR scenarios as well as AR scenarios, is the current workflow to request a WebXR session requires some user gesture activation. 2D pages usually have a button that's like enter immersive mode or something like that, because we want to make sure that pages can't just take over the display without the user's permission. But sometimes you want to do in VR navigation between different VR worlds, essentially, and do that without loading a 2D page in the middle. And we're trying to figure out how we can safely do a standard mechanism to explicitly grant those sessions. Now, browsers still have the responsibility to inform users, ask for appropriate permissions outside the context of that 2D page, but this is an important scenario in the use cases that we think is interesting for the future. So with that, I want to hand back to Ada to wrap up, and we can take some questions.
Cool. Thank you, Chris. So yeah, these are the next things which we want to, which are on our highest on our priority in the standardization effort. First of all is to reach candidate recommendation for WebXR, augmented reality module, gamepad module, and a few other really stable modules. Because taking them to candidate recommendation is what is the next big step in making it an official standard. Right now, even though these have multiple implementations, they're still not official W3C standards yet. And so they don't have the same guarantees. And so by bringing it to these next steps, we can stamp it and say, look, we're very positive these will not change unless something absolutely disastrous happens. Like it turns out to be a massive security breach in one of the features. The next features we're looking at are the ones which are bringing more web features to WebXR. So this is from the ones that Chris has recently mentioned. So these are the ones that bring DOM content into WebXR itself, and the ability to do navigation between different web pages. After all, the web has been doing navigation for about 30 years now, and it probably shouldn't be something we leave behind in WebXR. And we might have, well, not say we, but Oculus are working on an implementation for navigation between pages on the same domain. So not from like example.com to adaswebsite.com, but from adaswebsite.com/page1 to adaswebsite.com/page2, for example. So yeah, that's very cool and very exciting. And we also really want to bring the more advanced XR features to developers. After all, even though many developers are just building 360 video things, we still want to support the developers who are really pushing the envelope to build, to really see how far this technology can go. And a lot of these advanced XR features really do require some quite dangerous amounts of access to the user's information. So striking the right balance between giving power to developers but security to users is really where the challenge lies. And so we really do need your help in testing with these APIs and giving feedback. And even if you want to read through the GitHub issues and leave comments and see how stuff is going, it's always more than welcome. So thank you so much for listening. And if what we've talked about today has been like really interesting and you want to see like where the APIs are going, here's how you can take part. So firstly, just follow the GitHub repos, see what's happening, read some of the issues. There's some really interesting conversations happening there. Follow the Immersive Web Weekly newsletter, which Trevor puts together. It has a really fantastic overview of stuff that's happening in the standards efforts and in the wider XR community. It's really fantastic. And finally, if you're up to it, join the Immersive Web Working Group or the Immersive Web Community Group. Thank you so much.
Amazing. Thank you so much, both of you. Of course, we have questions. People want to know. So I'm just going to take over the screen here, and because I think I'm taking over. Okay. Yep. Here we go. Okay. So the first question, I've got 5 right now. In terms of adoption, how long did WebVR standards last? And now we want you to look into your crystal ball and tell us how do we know WebXR is going to last longer?
WebVR was around for a long time, like 4 or 5 years. because like it came around shortly after like the DK1 did, and Brandon was tinkering with his DK1, just trying to get it working. And the reason we can guarantee that WebXR will last longer is WebVR was just put together to be something that will work using the hardware that was currently available without too much thought for building something that was future-proof. Whereas WebXR has been designed from the ground up to be future-proof and to work on newer hardware as it arrives. And WebXR has already encountered like new surprising hardware which we didn't expect, and has adapted and worked with it. So we've already seen that WebXR can be future-proof, and it's been built to last.
It's going to be around.
I think it's
important. It's going to be around for a while.
Yeah, it's important to remember too that WebVR didn't ever turn on. It was never enabled by default in Chrome. And that actually kind of helped it to for us to get rid of it quicker, I guess, because WebXR was really based on a lot of the same concepts, but with the experience of, oh wait, what wasn't future-proof when we decided to go incorporating AR into the same sessions or into the same system, and different frame refresh rates for headsets and the like. So I'm share Ada's confidence that WebXR is going to be around for a long time.
Careful, nobody holds you to that one, Ada.
When we make something candidate recommendation, that's what we're saying. Like we're making that promise to the web community that we're building something that's high quality, secure, good for users, and future proof. Like that is the promise we're making as engineers. And if we mess up that promise, we've damaged the web for years to come by having an API that web browsers need to support, and it doesn't work. So we need to make something that works because we care about the web, and we need to make something that's going to last.
I think that's an important point, is that WebVR didn't ever go through the full process of becoming a W3C recommendation. Whereas WebXR, from the very beginning, the effort was meant to do it right, make it stable, and make it something that can last a very long time. So very different beasts, even though they sort of address some of the same root level problems.
So speaking of stability, somebody's asking if self-driving cars are going to be ported to WebXR. So we don't have to go down that rabbit hole, but maybe on a high level, do one of you want to answer that one?
Sure. I think it's an interesting question. And I would say some of the technology that is driving self-driving cars is really feeding into the same computer vision. It's doing the same object detection, not depth mapping so much as doing some of the object detection in the real world. I don't think that we'd ever do a one-to-one trade-off there, and I would highly encourage people not to build their self-driving car system on top of WebXR at this stage, or possibly ever. But I don't want to have the liability for that.
Not for today, anyways.
Yeah, but
not for today.
I do think some of the underlying problems are similar, and I'm sure some of the underlying algorithms are being used. That's why we want to try to enable whatever native platforms can give us.
Yeah, that's really interesting. Okay, the next question, and I'm just watching our time. We have a couple more minutes, and I have a couple more questions. A very compelling use case is AR in VR, essentially enabling immersive AR mode for desktop VR use cases. For example, to use VR gadgets and other VR experiences, landscape mode versus immersive mode, if you will. What are the odds of seeing that land in the specs?
This is something which we have had brought up occasionally. It's something I personally would like to see. I would like to have the ability to run immersive AR sessions on top of immersive VR sessions. Like if you're running an already immersive VR session, you open up a new tab in your VR browser, start an immersive AR session, and then it uses the depth information from the VR scene to fill in some of the APIs. I think that would be pretty cool. And I don't think there's actually anything in the WebXR spec that disallows it. It just needs a web browser to implement it, really. So Oculus engineers, if you want to like do that.
Hopefully they're listening in. They're listening in.
And a very similar thing which I'm working on as a side project of mine is an emulator for headset augmented reality using headset virtual reality. So you build your immersive AR scene and you test it on your phone and make sure it works. And then you add this drop-in library, and then you enter immersive AR, but in a headset, and it gives you like a virtual scene, and you can hit test against this virtual scene. And so you can test headset interactions, even though you don't own a augmented reality headset, you just have a VR headset. But that's just a side project of mine, which
sounds like the multi-metaverse to me. Well, that's awesome. I think we have our next panel coming up. So I'd like to thank you, both Chris and Ada, for joining us today on this very special panel, and keep doing the great work that you're doing. We all very much appreciate it. And I think I can speak from the couple of hundred people that are watching that we all say thank you. So,
well, thanks so much.
Yeah, thank you so much for having us. And I'm sorry Aisha Gould's having technical issues, because she would have loved to have been here as well, and as the other co-chair.
Yeah, yeah. The three of you are doing amazing work. Thank you so much.
Hey, thanks.
Thank you. Bye.
All right. Thank you. And passing it back over to Trevor to start your panel with Genevieve and Jacob. Hi, guys. I'll leave you guys to it. Thank you so much for joining us today.
Thanks, Julie. Hello, Jacob and Genevieve. Thank you so much for being here.
Thanks for having us.
Yeah, I think it's actually a perfect roll-in from the last discussion that we had. You know, some of the follow-up questions that the panel, that the co-chairs received were about the future of what browsers can do. And, you know, obviously they talked about WebXR, but I think there's the bigger context that you two are uniquely positioned to talk about. Just as a little background for everyone listening, Jacob works on the Oculus browser, and so obviously right now the main platform for that is the Quest platform, which is a virtual reality platform. And Genevieve works at Magic Leap on the see-through AR headset that they make on the browser on that. So we have a sort of a, as much as there's diversity within immersive browsers, that's what is represented here today. So thank you so much for being here. So one thing I want to sort of put to both of you is to talk a little bit about the context of how the browser fits into the platforms that you both work on. I know that obviously a lot of people watching today are either already or are sort of getting into web development for XR, but it has never been obvious that the web browser is the place to do XR development, especially on these new platforms. So Genevieve, maybe you can start off by telling us a little bit of how your team and your company as a whole thinks about where the browser fits in with the rest of what the platform offers.
Yeah, that's a really great question. And I think those are the questions that are industry wide. Like, how does the browser fit in AR at all? And also, in like, how does WebXR fit in, with the developer community? So we all know what the benefits of the web are, right? It's ease of building, ease of distribution. The ability to get up and running really quickly, and to get your content out there, quickly. And I think that's really where the draw is. I guess where the drawbacks are that it's still not that easy yet. It's, there's still the standard is still evolving, and it's settled a lot. It's much more useful than it was when we first started on it. And that's a testament to all the people at W3C and part of the Immersive group who have been making it. But it's also still not quite there yet. And I think it's actually, in some sense, it's bad that it's not quite there yet, because this makes it hard for browser browser developers like us to implement the right things. But it's also good because I don't think we, as an industry, know exactly what needs to go into it yet. So it gives us an opportunity to pivot and to put in the things that are the most important, as opposed to just blindly implementing, every and any passing idea that comes to our head.
Great. And Jacob, same question to you.
Yeah, I think the role of the browser and the web on Oculus has kind of evolved over the years. It really started out with a pretty specific focus on WebVR. In fact, it wasn't really even a browser. Project Carmel was like this WebVR player with a gallery that opened up to a few canned experiences, and over time it became a full-featured browser to today, where it's one of the most popular apps on Quest. I think that speaks to a lot of what Jen was saying around the role of the web, how easy it is to get up and developing for it, and also from the user perspective, just how much content there is, right? This is a new platform, immersive computing, and so having access to billions of pages and a diversity of use cases and content is something users want. And I think the fact that the browser is one of the most popular applications, it just kind of lines up with that really well. And so that makes us think about it as, a core part of people's experience with Quest. And so we invest in it as one of the main pieces of our experience. And in fact, the browser and the web's kind of pushing the boundaries on what the overall experience in a Quest headset looks like, with some of the stuff we've talked about over the last year, like infinite office and multitasking. That was not how Quest worked, when it first launched. And now you have multiple apps running at the same time. And a lot of that was driven by use cases from the web. So it's very much a core part of the platform for Oculus.
Oh, that's really interesting. As a web developer, it has always seemed obvious to me, of course, that the web was a natural way to produce XR. But it's interesting to hear that it is not just a sort of a bolted-on thing, but it's actually sort of becoming something that defines what the platform as a whole can do. Genevieve, do you have any examples or any sort of, are you seeing the same thing within AR? I know that the scale and the types of deployments that we're seeing for AR versus VR are pretty different. For more enterprise-focused work, are you seeing similar sort of, reverse flow feedback from web usage into the native apps?
Yeah, we see actually a similar thing to what Facebook had, where the browser is actually one of the more popular applications on our device, and we do see some uptake with AR and specifically with enterprise around data visualization and communications and things like that. So we are seeing, definitely usage in that direction. There's also, I think, a lot of, a great portion of developers who want to use the web, who are asking for new feature, this feature and that feature, and we will funnel those up through W3C. But they're certainly asking to use it because they see the benefits of it.
That's great. One aspect that I have been curious about for a while is not just at the application level, but also sort of at the operating system level. There's obviously a lot of places where web content or web applications can be sort of more tightly integrated into the operating system itself. So obviously on desktop and mobile, we have sort of installable web apps in the form of PWAs. And then also in mostly desktop browsers, we have things like web extensions that let you actually change the nature of what your web browser is doing and sort of interact more tightly with the operating system in a lot of cases, like accessing files or local resources in a different way. For either one of you, as you think about how your browsers will evolve, what are sort of the forces that you see for OS integration?
Yeah, I think yeah, I've been pretty public about how we're exploring PWAs for VR, and I think a lot of the motivation there is exactly what you're talking about. It's how do you make the web a more integrated part of the overall device and operating system experience? How do you help web developers have access to some of the discovery and distribution mechanisms that are made available to native apps? And how do you help users get the muscle memory around like launching these apps from their library and like having them more integrated into the overall system experience? I think that is something that's really interesting and lines up with a lot of the addresses a lot of the feedback that we hear from both developers and users. Of course, installable apps is like just one way to do that. I think the other angle here is ensuring that we're making all of the new device capabilities accessible to the web and web developers, and I think that's the name of the game in the Immersive Web Working Group. It's one of the reasons why we push things like bringing hand tracking in and making developer technologies like time warp layers for better performance. Like all of that is about helping web content work at a higher level and at the same level with native and be more integrated with the rest of the system experience.
Yeah, I agree. And if you take a look at sort of what you do every day, even outside of WebXR, back into the flat web, I mean, a lot of we're having this conversation over the web, this video conference over the web. A lot of our tools, our email, our calendars, those are all also available through the web. Whatever systems you use in your day-to-day job, ticketing systems and like wiki pages and all the like data analysis tools that you guys do at your job, those are all available over the web. And so having a way to distribute those and package those up for users on a headset type device, I think is really, really important. And it's another way to access that kind of content. Yes, you can share links, but also being able to download something or push an app to a device, especially in the enterprise context, is really helpful. So Magically did ship some progressive web app support back. I can't remember. COVID has warped my brain, but quite a few releases back, actually. So we've had that support for a little while, and it's definitely something that we think is important going forward. It provides a bunch of benefits, and especially in WebXR, because maybe in WebXR you don't need to, if you're going to launch an app, maybe you don't need to like click through all the screens required if you have a progressive web app. And I think that's one of those things that both users and developers have found really frustrating is the transition from flat web to, especially on headset devices, like an immersive experience, a stereoscopic immersive experience. So I think there's some things that might be safer to do in a web app that wouldn't be as safe to do just by clicking random links. And I think that's an opportunity for all of us to leverage that the amount of scrutiny that goes into an application over a random link.
Yeah, I think that's an excellent point. Like, it's one of the things we've been seeing as we explore this as well. Like, that today, for very intentional reasons, there's a permissions model around getting access to WebXR. But you can imagine a PWA that is directly immersive, exclusively immersive, just like a native app. But there's no, PWA manifest doesn't have like display mode that's immersive, and so there's gaps like that I think we still have to close as a platform.
Yeah, I think we're at a really interesting point because, in part because it was the sort of lowest, the most important piece. We have focused on these sort of fully immersive sessions that sort of take over and take over your entire display, and the WebXR session API is specifically for making sure that we do that in a safe, consistent way across random websites that may have different intentions. And so, right, these it's an interesting time because we can move forward, and like you say, we can change some of the permissions assumptions about PWAs. But I think we're also at a point where we're hearing more and more that people want to also be able to run, gadgets or small apps that don't necessarily take over your entire display, but maybe they run while you're doing something else, and they are spatial and they are three-dimensional, but they're not sort of the fully immersive WebXR session. I know a lot of people think about that specifically for AR, but I think it's also true in VR. Have you been hearing from your users that this is the kind of thing that you would like to work towards? Is that something you hear a lot?
Well, I think today the user experience of the web, at least in VR, is very, very bimodal, right? Like you either have 2D web pages or you have completely immersive. And there probably is an opportunity to blur the lines there and create experiences that across the spectrum of that. I know we've had conversations in the working group around things like being able to peer through sort of a window, like a diorama style experience into a 2D web page, or what would it mean to be able to just embed a model into a 2D web page and have it float off the page, and I think that is both interesting from a use cases perspective, right? But also a developer one, right? You've still, the number of 2D pages relative to the immersive enabled web pages is astronomical. And so providing developers a way to progressively enhance the P and PWA really, and add in and layer in immersive capabilities, I think is really interesting as a way to kind of grow adoption. Don't have anything specific to announce there, but I do think that is an interesting place that right now we've kind of got this two distinct experiences, and they could probably be made more harmonious, and we probably uncover a bunch of really interesting user experiences in doing so.
Yeah, I think Magic Leap does currently support multi-applications. We call them landscape applications because they can sit in your landscape. As far as usage, I don't know that people are really ready for that yet. I think, for us, we're into tech. We understand 3D to some extent, and we're willing to suffer the consequences of emerging technology and put up with a lot of things to see our visions realized. I'm not sure that the rest of the market is ready for that. I think 3D is still very confusing for a lot of people. I don't think we've cracked all of the usability issues around having multiple applications and multiple windows, and losing stuff as you walk around. Like, where did I put this? I lose my phone daily. And so the same thing kind of happens to screens in some senses, right? Or to any 3D widget I might have floating in my space. I think there's some obvious use cases for consumers, like having screens and calendars and Tamagotchi widgets, things that you might weather apps, those kind of things that we might enjoy. But whether those transfer over to enterprise and whether consumers are ready for it right now, and I'm not totally sure. We're quite there yet. I think maybe we're a little too early to the party for that kind of thing.
Yeah, I think on the 3D end of that spectrum, it's definitely more speculative. I think where we're seeing some of the demand for what we're talking about is on the 2D end of the spectrum, but in VR. I mentioned earlier around our work with multitasking and infinite office. That is something we hear very loudly from users. Humans are sort of inherently productive beings, and they like to do lots of things at once. So whether that's just a video on one side next to you're catching up on email or whatever it might be, we hear a lot of a lot of demand from users to be able to leverage VR for that, because VR gives you this like infinite screen, and you're not limited by the choice you made 2 years ago on what monitor you have or how you have them placed or whatever. And so that's definitely something we're working on. As it expands into like actually having 3D objects and widgets, that's, I think, something yet to be figured out.
Yeah, it seems that once we got to be able to build things like completely in 3D and immersively, what we realized was that we actually wanted some flat things in there as well, like screens, text, and things like that. And I think that's kind of really interesting. But I think it makes a lot of sense because, what are we used to? We're used to flat screens. We're used to reading books. We're used to reading phones. All those things are like pretty flat. And there's a reason why we didn't all 3D print all of our books or use cuneiforms anymore, and because it's more efficient for it to be flat. You got a density information that way. So I think that's really interesting, and to see how this is going to migrate going forward.
Yeah, I think one of the running jokes about being working both on specs and on the software for the immersive web is that one of the #1 questions is, how do I put HTML on a texture in the 3D space? It's one of those things where it seems counterintuitive until you actually try to build things and you realize, right, we use flat signage everywhere because it's incredibly useful, and we need to sort of we can't leave that stuff behind as we move into spatial design.
Yeah, I mean, Magic Leap, we kind of moved. We in addition to doing WebXR, we kind of also took an approach of like, hey, let's take a flat thing and make it more 3D. Maybe that's outside of the scope of this discussion, but we have found that people wanted something like that, and if we can find a way to merge the two approaches, I think that makes a lot of sense. People already know CSS, so if you can use, and there already exists 3D CSS, so can we leverage that to somehow make 3D web pages, no matter whether it's immersive or not. And same with 3D models. There's Magic Leap has the prismatic models. There's also the model viewer that's a component. There's Sketchfab and whatever other rumors are floating around with other industry leaders. So I think there's a lot of interest in that, and like web pages, you just like add an image to with an image tag, and it's really easy. So how can we bring in some of those? How do we simplify some of those more complex 3D concepts? Back for more flat web developers.
Yeah, I think both directions makes a lot of sense. If we have the spectrum of like 2D content and completely immersive content, like how do you bring the 3D stuff into the 2D world? And then as you said, Trevor, like how do you bring 2D content into WebXR? A lot of tough challenges with that one, but it's one we're really passionate about because we think it unlocks a lot. And I think it's important to acknowledge this isn't just a web problem either, right? This is on a native, like building 2D UIs in game engines and things is actually quite hard, and the tooling there is not quite that sophisticated. So if we're able to unlock that on the web, like give you the full power of CSS and HTML5 and everything, like within a WebXR space, like the world is your oyster.
Yeah, and I guess another thing to mention is that rendering text in 3D legibly is not an easy problem to solve. Game engines, they do highly specific things to optimize it as you walk around, in a 3D space. And to do those things, without like a manual intervention, and to make it, good all the time, it's not an easy problem to solve, and I'm not sure anybody has solved it perfectly yet. I think we still have a long way to go, to make it to make it really good and to the level that I think consumers expect.
Yeah, I think that the Troika toolkit is one of the JavaScript libraries out there that's really focused on good font rendering, and it is non-trivial. I will say, every time I poke into that code, I am impressed with the level of effort it takes to actually pull that off in a legible way. So one thing that I want us to get to today is to talk about, sort of look a little bit forward, and maybe even beyond. You know, I know that both of you got into this work not just because of the existence of the company that you work for, but because you're interested in general. But sort of on a personal level, when you look forward, you know, 5 years, what would you like to see? You know, what's the story you would like to tell about how the community came together and solved problems, you know, on a global scale that got us to some vision that you have about this future? Maybe Genevieve, if you'd like to go first. Yeah.
Wow, that's something.
It's a big question, I know.
Yeah, it's a pretty good question. I mean, I think what would be helpful, I mean, is a few good use cases. You know, I think we've got games, you know, we've got some, you know, cool art experiments and other things, but to really draw people in, you want to, I mean, like, I guess like we work in tech because we like cool things, right? And we're willing to, you know, we're willing to fiddle with stuff, and we're willing to work on stuff because we think it's interesting, even if it doesn't solve a problem. In my personal life, I don't buy any piece of tech unless it like does something for me or makes my life better. I'm kind of a Luddite, actually. Even though I'm very like high tech in my work, I'm kind of a Luddite in my personal life. And I think for a lot of people, that's going to be, you know, a similar reason is, you know, why would I need this? And until we have a thing where either it's like, you know, it's a lot of fun, or it really helps with our communication, or we can use it for, you know, we've really ironed out all the kinks in some sort of like learning module or enterprise use cases. You know, so I think as an industry, once we figure out what those things are, we can rally around the technology, and really build that out for those use cases while keeping all the other ones kind of, you know, that the future thing that we all of our hopes and dreams, you know, we can still keep those in the path, but, you know, at least we have something to drive towards. So I think we'll start seeing that soon. I think we're kind of on the cusp of, you know, stuff getting good enough that we can really, you know, use it to solve things. I do get a lot of sort of asked like, hey, can we use WebXR for this? Can we use WebXR for that? And, you know, a lot of times my answer is almost, maybe, soon. And I think we're almost at the almost maybe soon, and then we really start to see stuff take off. And I think the other really big thing with WebXR specifically is you know, tooling, and you know, the ability to, you know, have really great sort of not just developer tools, but like for artists and creators, and people are again solving problems. And because the standard's not there yet, I don't think the tooling's there. Right. We want to look back into our messy web history at Flash. You know, one of the great things about it was, you know, the great tooling that came with it. Even though Flash itself had its problems, you know, we saw a ton of content, a ton of solutions were written using Flash for various reasons, and one of those was great tooling. So I think we really need to, you know, as an industry, if we want it to succeed, we really need, you know, that side of the industry partners to come up with a great solution, and I think we'll see more uptake.
I think that's a great point. I still see artists mourning the loss of the Flash tooling because it gave them so much power. Yeah, I think that would be a great vision if we could look back in 5 years and say, we now have something that is fondly thought of as Flash was before. Jacob, how about you?
Yeah, well, it is an ambitious question. I think I like ground myself in the answer and reminding myself that like at least WebXR itself is still in its infancy. It's about 18 months or so since it was on by default on the Oculus platform. So, you know, we should level our expectations around where you know, content and the ecosystem should be at this point. And I think over those 18 months, the growth curve has been really impressive. You know, I think we've gone from just a lot of like lightweight tech demo, you know, like proving out the APIs and demonstrating kind of signs of life of VR capabilities, and to now where, you know, it was a ton of fun to work with. I'm so happy you're chatting with like Active Theory and like working with them on like Secret Sky, seeing like blockbuster VR content built on the web. You know, the work that the impact that things like hubs or Frame are having in the enterprise space, creating social experiences. You're starting to see content really mature, and that is really exciting. So at this stage, I think the name of the game is building a tighter loop with developers to understand what are the pain points and what are kind of keeping them from going to the next level with that content. And we've been doing a research study with a lot of developers working in WebXR. Out of that, we hear a number of different things, and we're trying to have a fast kind of response time to things that we hear from developers. Like one of the things we heard was, we recommend content in the browser and try to drive discovery of content, and it wasn't clear how do you get into Oculus's recommendations. So we published a bunch of developer documentation on that. As we started to explore PWAs and really just this larger platform, we realized documentation isn't really that great today. So we've joined the Open Web Docs, and that's going to be a big push for us around helping fill out the resources that developers need to understand this novel technology. And then I think it's helping them actually be successful, investing in partnerships and relationships to help push content boundaries, push discovery, push engagement, solve problems that aren't solved yet. Monetization is still challenging in this space, so pushing the envelope there and really listening to developers, I think, will be key. And yeah, I think Jen's right. Tooling is a big ingredient of this. It's still at a very early stage. There is no killer framework yet, or frameworks. And I think we have big shoes to fill relative to where tooling is at for native 3D content. And I think there's a lot of work to go there as well.
Yeah, I agree. We're seeing signs of life in things like the Metaverse session that we saw earlier, and Wonderland and Play Canvas. But yeah, I agree. Thank you both so much for coming on and telling us about where you are today with the browser and where we're headed. So I appreciate it a lot. I know that it is the enabling piece for a lot of these sort of far-reaching visions. So thank you so much.
Thank you, and thanks for setting this up. This is an amazing event.
My pleasure.
Thanks for having me.
Yeah. And then next, we'd like to welcome Oleg. And Oleg's going to talk about his work, on the React toolkit, React 3 Fiber, and basically how he's integrating the immersive web into this huge ecosystem of React web development. So thank you so much, and I'll turn it over to you.
Thank you. Really excited to be here. This is my first presentation in a public conference. So hi, my name is Oleg, and I'm a web developer. And in my free time, I like to play around with anything VR or AR related. And in this talk, I want to share with you a project that I've been doing for some time now. It's called WebXR, and it builds on top of React 3 Fiber and provides web developers with components needed to quickly build VR applications with React. So this project is all about giving tools, components to developers to easily create WebXR experiences. First, I want to talk about Pymandres. It's an open source developer collective, which ReactXR is part of, bringing you such libraries as React Spring, React 3 Fiber, Zustand, and so much more. So if you want to join, we have a Discord. Any questions will be answered. And yeah. So first, let's talk about React 3 Fiber. So it's a library that allows you to use all of the 3JS in React. So 3JS is a powerful 3D engine, and React 3 Fiber ties it together with React. You get declarative way of making apps and games. You have huge existing React ecosystem that includes animation libraries, state management. So every library you can use in React, you can use it here. And also growing number of libraries in the React 3 Fiber ecosystem. So for example, like physics library use Canon, a collection of useful helpers try, and React Reflex for 3D layout. We also have accessibility library to enable navigation with keyboard, for example, and of course, React XR. So React XR is a library that contains React components to help any React developer start creating XR experiences in no time. Because it extends in React 3 Fiber, you can use all of the libraries. Like, for example, you can see here the library use Canon is used. So it's a physics engine that works out of the box with the React 3 Fiber. Just add a couple lines of code, and your objects become interactive and physical objects. And all of those examples you see on screen are extremely simple. They're like 100 to 100 lines of code and available on GitHub. So I encourage you to check them out. So let's look at some of the components that are available for you in React XR library. One of them is default XR controllers. It's a one line that you can add to your app and have full models of the controllers. Underneath, it uses WebXR input profiles. So it loads a controller of the device you're using. So for example, if you have Oculus Quest, you'll see Oculus Touch controllers in your hands in your app. Another component is hands. And with one line of code, you can add hands to your app. So you will be able to physically see your hands and mesh on the device that support it, like Quest and Quest 2. And on the side note, it's kind of incredible to have an API for human body. Like, can't wait to have an API, for example, heart rate or user's mood. I'm sure something like that already exists somewhere deep in the Facebook Reality Labs, but that's another topic. Another component is interactive. So let's say you want to attach some listeners like on click, on hover, on blur. So you wrap any object in a scene in this component, and it becomes interactive. So it's super convenient if you want like build a button in a couple of seconds. And so let's say you want to create your first React application or a game. How would that look like? So to get started, we'll get started with like a regular React app. You have your main app component. So first thing you do is add VR or AR canvas. So this will create an empty scene with like a button to start immersive session. And even at this point, you have fully working application that you can launch without anything in it yet, but still, it's that simple. And then let's add controllers. So the controller component discussed previously, it's just one line of code. And let's, for example, add some content to our app. So let's add Cube for dry library. And right now we have a VR application with controllers and some content in just a couple lines of code. And to show the power of the React 3 Fiber ecosystem and how easy it is to get started, I want to show a little demo. So recently, Poemandres launched Market, which is a website with a bunch of free models licensed with Creative Commons. So you can use any of those in your app. And let's see how easy it is to create an app and place some model in it. So I'll be using Code Sandbox, which is a really useful tool to be able to get started with any web project, and especially React XR. So I'll use my template with just a basic scene that contains just some lights. And let's look how easy it is to add a model. We'll choose an apple. Over here, you can see you have a React 3 Fiber section, which is super convenient, and you just copy import. After that, you add it to your app, import the appropriate loader, And let's put it in our scene. So another awesome thing about Directory Fiber is that you can take advantage of existing React features like suspense. So you don't have to manage asynchronous code. You already have it built in with React. So let's edit model, position it somewhere in front of me. And let's add some hands. And just like that, we have a working application with some imported model. So let's check it out and look how it looks in VR. And so I want to give out a big shout out to Oculus team for making Developer Hub, because if you're using Quest and developing for WebXR, this is just an incredible tool because you have ability to like disable the proximity sensor, open links in your device, or cast the device. So let me get my Quest. Okay. So let me exit from the previous. And let me cast it to you so you can also see, not only me. And let's open the link in the browser. Okay, so we can see that hands are present in the app, and we can see the apple. We can touch it. Right now, you can't do anything with it, but it's all that will be put there, hands and the model. So just like that, in a couple of minutes, you have a fully working VR application. You can have your URL, you can share it with anyone. And it's really incredible how easy it is with WebXR to create and share experiences. And ReactXR is already being used in a while. And one example is a puzzle game called Pluckle, which is made using React through Fiber and ReactXR. You can find it right now on the Oculus browser page. So with over 2,500 hours played and 15,000 players, it proves that WebXR and React Fiber is a viable platform for game development. And I encourage all of you to try it. It's a really fun puzzle game. And so in closing words, I want to say that the WebXR platform is truly incredible. Like, not only is it frictionless, user-friendly, and easy to use, but it's also an open platform, so you can create it once and open it on any device. One major thing that makes me love WebXR is how incredibly low iteration times are. Like, it's so satisfying to being able to write code, instantly see it on the screen, experiment with any ideas. For example, the ones you see on the screen right now is just experiments that were made in like under an hour. It's just plain fun to be able to explore and discover this new technology in user-friendly way. And I'm really excited for WebXR future, and I can't wait to see what you all build. If you want to start with ReactXR, and go to the GitHub page and let me know what you think. Thank you. I think you're muted. I cannot hear you.
Hi, Rick. Oh, I am muted. Sorry, Oleg.
Hi.
You did a great job. Thank you so much. I was just saying, if you hadn't have mentioned it, I would never have known that this was your first presentation to a conference. I think at my first presentation, I fell off the stage as I was exiting, and I will never forget it. So you did a great job and such great content. It's great to see that the work that you're doing is enabling so many people to jump in without, spending months and months just getting the basics working. So I really appreciate that you've done that work.
Thank you.
So one question that, it's the question I'm asking so many of the people that come on today is what are the sort of big missing pieces that you need from either the standards community or from the browser implementers that you feel like if they could either speed up or start working on, that would help you progress your work?
So definitely one of the exciting features that I'm looking forward to is being able to use Oculus pass-through in applications. So it would be great to be able to start developing AR applications on VR devices, because I think the AR is where all the current industry is heading towards, like mainstream AR glasses and stuff like that. It's really exciting to see the progress in that area. And also, the WebGPU is definitely something to keep an eye on, because the performance is definitely one of the things that is currently, I wouldn't say lacking, but it's still something it's never enough performance.
Right, yeah, it's sort of the unending work for not just the web, but for every one of these platforms. Are there specific things that you would like to ask the community to pitch in on? I know that you're part of a collective that works together on a lot of these projects and sort of has a collective chunk of work that they're going for. Are there specific things that you would like to ask the community to show up and help with?
Definitely, if you are a person that wants to try and start developing VR applications or AR and have questions or pain points or any issues you're having, that'd be a great feedback to have an idea on what to work on or what to focus on, because this project is really about empowering people to build great and amazing experiences. So if you have any pain points, then yes, go ahead and open up an issue. We will gladly look at it.
Well, thank you so much. I really appreciate you coming on and talking about your work. And we're going to move on next to Jason Johnston. He's from Verizon. He's going to talk to us about performance and optimization, which seems like a natural sort of follow-on to your work, Oleg. So, Jason, I'll leave it to you, and thank you, Oleg.
Awesome, great. Thank you, Oleg. If you can still hear this, I'm a big fan of your work and the R3F community in general. So,
thank you.
It's great. All right, let me share my slides. I think maybe this is coming up. There we go. All right, hey everybody. My name is Jason Johnston. I work at Verizon. I work specifically in the network security group there. I build UIs and data visualizations for network security, and I utilize a lot of 3D and XR. I also build tools to drive a lot of those experiences, and a lot of those that I've managed to open source under the Troika project, which it includes a sort of React-inspired scene management framework oriented around performance. But probably the most popular part of it is its text rendering library for very high quality text. But I'm not talking about that today. Today I was thrilled to be invited to talk to the community about performance and optimization. It's a huge subject. And then I realized I only had about 10 minutes to talk. And so this was an exercise in optimization itself. I really had to focus and say, okay, what am I going to focus on in this talk? I decided that what I should do is really focus on a very high level, define what our performance constraints are in a WebXR environment, give a little bit of an overview of the general approach that I like to take when I start thinking about performance, and finally talk a little bit about some things on the future horizon that can help us out. To narrow the scope even further, this talk is going to be totally based from my personal experience. And I came into this space as a traditional web developer, trying to get into 3D and XR. And a lot of my work is mostly in UI and data visualization. And I think those things tend to be more like diagrammatic in nature. So I don't typically deal with very complex geometries or large textures, but I can have a lot of very simple objects that are very dynamic. And that definitely affects where my bottlenecks tend to occur. Also, my experience is also almost entirely in the Three.js community. So some of these things might not directly apply to other rendering libraries. Finally, I want to mention that most of what I'm going to talk about isn't necessarily specific to WebXR. It really applies to any WebGL work that you might do. But many of these problems tend to compound themselves once you step into WebXR. So let's get started. When we talk about performance in WebXR, what we really mean is frame rate. That's what's crucial. That's what's hard to maintain. So what kind of frame rate are we talking about? Let's take the Oculus Quest 2, for example. It's perfectly capable of driving WebXR content at a full 90 frames a second. If you can do that, you're great. I find 60 frames per second is perfectly good, perfectly smooth. 45 frames a second, this is where you start feeling a little bit of jitter, a little bit choppy, but it's mostly acceptable in that range. Anything below that, however, you're getting into the danger zone for causing motion sickness. And I tend to be a little bit more sensitive than a lot of people to this. It definitely affects how much time I can spend in VR. Something else I want to mention is the frame rate's important, but also what's important is the steadiness of frame rate. If most of your frames are very, very fast, but you have some situations where maybe you're doing a big scene update and you drop several frames in a row, that can be super bad for the experience as well. So keep that in mind. So with our best case of 90 frames a second, that's about 11 milliseconds per frame in which all of your work has to occur. That's a very different sort of performance limitation than web developers like me might be used to. I think the rule of thumb used to be 100 milliseconds for visual feedback for users to feel instantaneous. Totally different than 11 milliseconds. And so let's try to break that down a little bit. Within that frame, you've got things that happen on the CPU and then on the GPU. On the CPU, a ton of things that can happen. Incomplete list here. Physics simulation, animations, updating poses. You're probably doing gray casting maybe twice if you're using both controllers. Event handling, other game logic, etc., network requests, data processing. And then finally, you get to 3.js render process, which itself does a lot of things behind the scenes until it gets to issuing draw calls to the GPU. And you probably issue, if you're in VR, you're issuing those draw calls twice. And then on the GPU, stuff happens. I'm not going to go into detail here. I'm intentionally glossing over this for two reasons. First of all, it's way too deep a subject, and it's not really in my expertise. But maybe more importantly, I think, honestly, it's not that important in most use cases, at least in my experience. That's because once stuff is on the GPU, generally, that's going to run just as fast as it would be if you were driving it with a native framework. However, the stuff that happens on the CPU, this is where our web environment, our web execution environment comes into play. We're using JavaScript, which is a scripted language. We have garbage collection to deal with. It's largely single-threaded in nature. And so this is where we typically need to concentrate our efforts, I find. I'd love to dive into more detail here, but for time's sake, let me just kind of step through what goes through my head when I start thinking about optimizing an app. So this is the general process that goes through my mind. Number one, I've got to measure it. I've got to know what I'm dealing with. Number two, I start asking myself some questions. Can I do less? Can I do less each frame, more specifically? On the main, can I take stuff off the main thread, maybe put it on a web worker? Can I do less on the CPU? And finally, with what's left over, can I just do that more efficiently? Stepping in a little bit, how to measure. I like to have a frames per second meter in my VR scene that I can pull up at any time, gives me a nice overview. But anything more detailed than that, I need the browser dev tools, hook up the profiler. And from that, I should be able to get a nice flame chart of all my JavaScript calls, see what's taking a long time, and focus my optimization efforts there. From there, I want to start asking questions. Is there stuff that I can do less of? This might involve making some tough choices. Can you simplify? These are in no particular order, by the way, these questions to ask. But it's always something to keep in the back of your head. Can I do less? More specifically, are there things that are happening on every single frame that I can be smarter about and maybe do those only on certain frames, only when they're needed? Can I adopt a reactive model where I'm only updating things when they change? Can I do caching? Little sidebar here, I'd like to talk about 3JS. This is a 3JS specific problem. The matrix auto update flag. This is something that's true by default on every object. And what it means is that on every single frame, every single object is going to have its local and world matrices recalculated. And you can imagine that doing this on every frame can be pretty intensive. There is a way to turn it off and do it manually. However, that's kind of hard to do as an author. I think there's a huge opportunity here for framework authors, people writing frameworks that sit above 3JS to add some help here and manage this automatically. The Troika framework that I've created does this, for example. I think Mozilla Hubs has something similar. I don't believe that React 3 Fiber or A-Frame do something similar, and so this is an opportunity perhaps for those frameworks to look into. Not only does cutting out matrix recalculation save some time every frame, but it turns out that once you track and know when individual objects are changing, you can do other smart stuff. For example, in Troika, I use that information to maintain an octree for much faster raycasting, and also for automatic instancing. All right, so back to the questions. Is there stuff that I can parallelize into a web worker, take it off the main thread? Anything that's data intensive and can work asynchronously is a prime target here. Point you briefly to the Troika work utils package. Has a few utilities there for making that a little bit easier. Can I do less on the CPU? Put differently, can I take advantage of the power of the GPU to make things faster? The big thing here is, this kind of maybe doesn't fit exactly into this slide, but one of the biggest wins that you can have is minimizing your draw calls. Draw call is a command from the CPU to the GPU to render an object. And the fewer of those you have, there's a fixed cost per draw call, basically. General rule of thumb in VR, you want to keep the count below 50, and that can be really hard to do. Some techniques you might use are merging geometries together and using GPU instancing. 3JS has a nice instance mesh abstraction for doing that, for example. Something I've started doing more recently is using custom vertex shaders for things where I have a geometry that needs to be morphed every frame. So a quick example of that here on the right. Each of these sort of candy ribbons on the timeline is just an instanced set of box geometries that the vertex shader is bending into these nice paths. And that's super fast, super fluid. And the Troika 3 utils package allows you to have some utilities for extending built-in 3JS materials to make that sort of stuff easier. As always, though, you need to measure the trade-offs. It's not always a win to move things that way. And then what's left? Can I do it more efficiently? This is your normal micro optimizations come into play here. Some opportunity for WebAssembly to be used if you have sort of data intensive processes that could be converted to WebAssembly, so potential there. Okay, so finally, I just want to touch on some things coming in the near future that can help us out. Multi-view extension. This actually used to exist in 3JS. It was removed for various issues, not least of which is the lack of anti-aliasing in the official version. The upside is it could potentially cut the draw calls in half in VR contexts, so a big win there. WebXR layers, lots of potential there for performance improvement. Better tools for using WebAssembly. I'm just starting to get into WebAssembly, and it can be tough coming from a JavaScript background. So better tools there would help. And then the big one, WebGPU. When this comes to us, I'm not sure when it'll happen. This is going to bring a lot of sort of automatic performance improvements. My understanding is that, for example, that fixed cost per draw call will pretty much go away. So that brings me to the end of my word salad here. Thanks for listening. Like I said, a lot that I couldn't cover. But if there are any questions, I would love to take them in the final minute here. I'm not sure if anybody is around to give me questions. Hey there, Trevor.
Hey, Jason. I think looking at the timing of it, I think we're actually going to have to skip questions today, but the Slido is up. So I think maybe one way to handle this is that, one, we have an after party, so people will be able to find you afterwards, hopefully, but then also, where can they find you on Twitter?
On Twitter, I'm Logic. That's Logic with 2 J's instead of a G.
Okay. Next up, we'll have Ben come on, and he will thank some of our sponsors and then roll us into the next session. Jason, thank you so much for coming on. And yeah, Ben, take it away. Okay, it looks like Ben is queuing up. Yep, I want to thank all our sponsors, of course. Ben mentioned a lot of them. FutureWay, obviously, and Zapper. I suspect that Ben will come on in a second to talk about sponsors that are for this segment. After that, we will roll into Conal Gauld, who will talk about universal AR. And then after that, we'll take a break. I know that we're going on 4 hours now for this session, which is a long time. We're almost halfway through the day, if you can believe it. This slide, I think, actually represents one of the things I really love about the WebXR community and the immersive web in general, is that when we ask for help, people show up. The Immersive Wire, Zapper, FutureWay, KaiXR, we put out the call for help, and I think I had, out of everybody that I recruited to come and talk today, I think I had one person who was a hard no, and everybody else either tried their best to make it happen or are appearing here today. So I love this community for that. I thank you so much for the sponsors and all the rest of the people that are on this slide for coming out and helping us to make today happen. I really appreciate it. It looks like we're now going to roll into Conal, who is from Zapper, and he is going to talk about universal AR.
Hi.
Hello, welcome.
Thank you. Great. All right. Well, yeah, I've got some slides. I better share those. 1 second. Share my screen. And here we go. Great, cool, yes. So I'm Conal, I'm the CTO at Zapper. I'll start with a very quick introduction to Zapper itself and talk a little bit about our universal AR SDKs, which I think is the most relevant and interesting of our technologies today. And then I'm hoping to squeeze in a live demo as well. So fingers crossed that all goes well. So at Zapper, we've just turned 10 years old now, which is quite a lot of years in AR years. Our business is kind of split into 2 parts. We have our Zapper HQ team who consult with and build augmented reality experiences for some of the world's biggest brands and companies. And we have our content platform called ZapWorks, which enables many thousands of developers around the world to build and deploy AR content on their own. And indeed, it's ZapWorks that we'll talk a bit about today. So ZapWorks has lots of different tools and elements to it. From an AR content creation perspective, we have two bits I'd like to mention. Studio, which is our complete 3D development environment for building AR, VR, and MR. But most relevant to our conversation today is Universal AR, where we've taken all of our computer vision algorithms and wrapped them into SDKs for a variety of different creative tools and distribution platforms. What does that look like? It looks like this. So Universal AR lets you build tracked experiences. So that might be image tracked or face tracked or world tracked, which we'll see in a moment. And it lets you build them with the content platforms and libraries you're already used to. So 3JS and A-Frame on the web, Unity also supporting its WebGL output, and the SDKs for JavaScript and C++. And so in each of these cases, we make available an SDK which speaks the language of that platform. So if you're a 3JS developer, for example, our Universal AR SDKs, they provide a 3JS group for each of the different tracking types. So you understand as the 3JS developer how it fits within your ecosystem. And the same is true of the other examples. And what the Universal AR SDKs have in common across all of these is unprecedented support across browsers and indeed native platforms. So for example, if you're building a project with Unity, you can use Unity's Android or iOS build outputs, or indeed you can use Unity's WebGL build output to target face tracked, image tracked, world tracked AR experiences built with Unity to Chrome and Safari on iOS. And likewise, if you're building content with 3JS, you can target iOS and Chrome and Safari on iOS as well. Indeed, since this slide was prepared, we've already introduced another SDK to this list, which is React 3 Fiber. And so what that does, it's an open source project that lets you build 3JS experiences using React library. It makes for a really interesting way to build content, and indeed our live demo will use that. Also, just around the corner, we have two new SDKs as well, one for Babylon.js and one for Play Canvas. So really a large number of content platforms and libraries that you can leverage with these SDKs to build AR content. So a little bit about how our Universal AR SDKs work. So they support the versions of Chrome and Safari that have been running on your users' devices for years. And so they don't have to enable any experimental build flags or experimental browser flags, I should say, on your users' devices. It runs with the versions that are just installed and running there already. So we don't use the WebXR API. In fact, our computer vision algorithms run in WebAssembly in the browser using the camera frames and device motion data that are provided through the standard web APIs. So get user media, for example, and we use web workers and these other primitives that are part of the web standards. And we'll talk a little bit later about what the pros and cons are of that approach versus using an API like the WebXR API that's built into some browsers. Now, with Universal AR, you can track different things. So we have world tracking. That's where users can place content into the environment around them. So perhaps product visualization would let you place a pot into your table for you to see what it might look like in situ. We have image tracking. So that's when we have a known target image, so a business card or a poster or a menu, for example, and being able to track that in 3D space and place content on or around that surface. And we have face tracking, so a bit like face filters where you can attach content to the user's head. We have landmarks, so you can attach things, for example, to an ear if you were doing an earring or a mustache. Not that I need one, but to place it on the top of your lip, and it would stay there. Or we also have what we call face mesh, and what that is it produces a surface that fits to your face and moves as your expression changes, and that fits the identity of your face. And so that would allow you to have, for example, a tattoo simulator or a face paint simulator. And often when we're building experiences using these technologies, we combine multiple of these technologies together to make really good experiences. So I thought, before we went in any further, I'd give you a very quick demo just to show you it in action. So I'm going to see if I can switch which screen I am sharing. And I'm going to share instead. So I'm going to open up Visual Studio Code here. Let me just see that that's coming through correctly in the channel. There we go, perfect. So this is Visual Studio Code. It's a React project, a relatively standard React project where we're using React 3 Fiber that allows us to build 3D experiences using React. You can see here on the left, it's a really pretty standard structure of a React project. So it's a node project. We've got package.json that's got our dependencies in it. And in fact, if we pop in there, we'll see in our dependencies that Zapper's React 3 Fiber library is one of them. If I go to app.jsx, this is the root component for my project here. And where I suppose if you're used to React just HTML, you'd expect to see HTML here. We've got some components that wrap around a 3D canvas and the AR tracking primitives that we provide. So here we have a Zapper canvas component, and inside that, a Zapper camera component. If I was just using normal React 3 Fiber, that would be a 3JS camera if we wanted to expose the camera directly into our component like this. We have a light down here, which so we can see. And then we have our instant tracker. So this is our world tracking technology in universal AR. And in our React 3 Fiber example, it's just a component. And anything we place within this component will be tracked to the position that the user chooses when they're placing this content in the experience as they have it. And that will become more clear in a moment. I'll show you the process of what this looks like for the user. But in this case, we're placing into this instant tracker a mesh. It's a sphere, and we're giving it a bit of hot pink material so that it has a little bit of visual interest for us. It's going to be just a simple sphere, so I don't think we're going to win any awards for the content, but it should hopefully demonstrate how easy it is to get some content into a world-tracked environment. Now we have a few extra arguments and parameters passed to our instant tracker. What they're doing is letting the user, or letting us configure for the user the placement experience. So how the user chooses where to put the object in space. And we'll see that in a moment when we try the experience. The content starts being in the center of the camera and will allow us to choose a location in space. There's a button on screen, which is in fact this div component down here. And when I tap on that as a user, that lets me say, this is where I want to place that content. So without any further ado, let's see it in action. Now, because this is a standard React web project, I'm using, I think React, the React, trying to click the wrong place. I think the React scripts to, React app rewired to host this in a development environment. So I think it ends up being Webpack behind the scenes. It gives me, in fact, if I just close that, I just go npm run start. That gives me a URL that is running on my local network that I can use to test the experience as I'm running it. So let me switch over to device. That involves another screen share change. So I have a iPhone XR, in fact, here, and it's relatively standard XR from a couple of years ago. So nothing special, particularly in its features or functions. And if I switch over to here. Hopefully we will be able to see it. So I've got it attached to my computer just for the purposes of being able to share the screen of the phone. I'm going to reload this page. So this is the page that's being hosted by that script I'm running in Visual Studio Code. Universal AR provides a standard permission prompt so that users can grant the necessary permissions, which are camera and motion data, to the page so that it can perform the AR experience. But this is all configurable and customizable. So because I haven't specifically in my project changed this, I'm getting the standard one, which fits in lots of circumstances. So I'm going to say grant access. And here we are in my room. This is just the table in front of me. And I've got some content that I'm going to place here. And there's that div at the bottom of the screen allowing me to tap to place that object. And when I tap that, the object now stays rooted to the spot, tracked in the world in front of me from the point I've selected. Now, I should say that, and this doesn't always come across well on screen shares, but from my perspective, this is running on the phone at full frame rate. So we get 60 frames per second from the camera, and we're rendering at least 30 frames per second in terms of the content. So it feels really smooth to me. At Zapper, we have a little joke that the experience is a buttery smooth and that it can't believe it's not native. So it's got to feel like I'm using a native app in terms of performance, which it does in this case. Cool. So I'm going to show you another quick example when I'm here. So I've got some examples from our website. So this one is a face tracked example. I'm just going to load it from a QR code. This one's built in Unity, which is a really nice way to build AR content for the web, it turns out. Let me just try reloading. Here we go. Made with Unity. And in this case, it's a face tracked experience. So let's grant access. Here we go. And it's just some simple 3D models attached to my head. But as you can see, like the tracking is super solid. Like it's really low latency. And yeah, pretty astonishing that it's running just in the web browser without any native help. Cool. Okay, so let's switch back to the presentation. And I think it's this one here. One second. There we go. And so I thought I would talk a little bit about the pros and cons of our universal AR technology versus using something like the WebXR API, because the approaches are quite different and each have their own pros and each have their own cons. So with universal AR, as I mentioned before, it all takes place in the web browser using WebAssembly and the other primitives that are provided as standard in the web browser, rather than the WebXR API, which we'll see in a moment, leverages the underlying frameworks as part of the operating system. So anyway, universal AR, it has more tracking types and computer vision algorithms than WebXR. And indeed, we're able to add new features and new tracking types very quickly to universal AR, and those be supported in all of our supported browsers without requiring those browser updates. And that's because the technology is just running in the web page. So if we have a new computer vision algorithm we want to deploy, we just add it to the library. We have full control over the camera and the camera frame rendering as a content developer when using universal AR, and that enables you to have more effects and filters. So as I say, it works as just a normal WebGL canvas, and it plays nicely with other HTML and CSS. So with universal AR, your HTML and CSS are not on a separate layer or in a kind of special layer in front of a camera like it is with WebXR. It's just a normal part of the 3D rendering of your experience. And that gives you ultimate flexibility for what you do with the camera and how you process it. We support multiple different camera sources. So what that means is you can process video elements such as live streams and perform the AR calculations on those, or indeed you can process the camera stream from another device if you wish, rather than just using the built-in camera on the device. And we should support both the shipping and older versions of stream browsers without any special feature flags, including Safari on iOS, Chrome for Android, and indeed now Chrome for iOS, Firefox, Chromium, and Blink-based browsers. And that's because pretty much all of these browsers support those core APIs of WebAssembly, web workers that we're able to rely on to work this technology and make it fast and feasible to run in a mobile web browser. And indeed, we can support devices that don't have ARKit and ARCore, which I suppose are the iOS and Android equivalent underlying frameworks that power WebXR through those platforms. And indeed, that includes desktop browsers, but also Android phones, for example, that don't have Google Play services, such as the devices that are popular in China. Now, on the other hand, WebXR has some advantages. So the tracking algorithms that WebXR exposes leverage those OS-level provided frameworks, so ARKit and ARCore. And what that means is they get access to native performance. So all of those fancy chips in your iOS device that can, I think they call it the neural engine, perhaps, that can perform lots of machine learning, computer vision technology, or indeed the fancy cameras like the depth camera on those higher-end iOS devices. ARKit, for example, can leverage those, and thus WebXR gets the benefit of them by proxy. And they get lower-level access to the hardware, which means, for example, that ARKit and ARCore are able to tie together data from the gyroscope and from the camera in a really closely knit and well synchronized way, whereas in the browser, we just don't at the moment get access to all of those APIs that allow us to access that data in the same way. Now, as you can see from our examples, you can still do a heck of a lot without those low-level hardware access elements, but it does mean that you're going to get the best native performance from WebXR as a result. So with WebXR, there's no licensing requirements. It's a technology that is embedded into the browsers, and so you can just use it freely as you would any other API in the browser. With Universal AR, you have a Zapworks subscription with us to authorize your use of the Universal AR SDKs. For hobbyists, we offer that for free, so you can be building content without it costing anything. And for businesses, we have a monthly subscription that you pay, and that at the end of the day pays our engineers basically to continue working on this technology. And indeed, with your subscription, you get access to all of our tools and hosting and a number of other benefits.
Hey, Connell, I'm afraid I'm going to need to interrupt. Thank you so much.
Okay.
We actually have some questions from the audience, if you wouldn't mind taking one or two.
Yeah, no, of course, we'd love to.
That's great. Yep, let's see here. Let me make my screen a little bit bigger so that I can read it. Okay, so I know the Zapier glasses had their go on Kickstarter. Do you think the web will be a part of the roadmap for Universal AR?
That's a good question, and there's a few different bits here. So Zapbox is our headset that we're building at Zapper. We've had previous versions of Zapbox made out of cardboard. The next version of Zapbox, which we've just, I think at the end of last year, had on Kickstarter, is made out of plastic, has 2 active controllers, but comes in at a sort of sub $60 price point, so way cheaper than other headsets. It will, in the first instance, be natively supported through apps built, for example, through Unity for iOS or Android. The reason for that is, in order for us to do the computer vision elements that we need to do, we would need to, I suppose, be a provider for WebXR in that sense. And since we don't have access to the to be able to, I suppose, implement Chrome or Safari and hook them in that way, it's difficult for us to support the web for Zapbox. That said, with our Universal AR SDKs, those SDKs target AR for mobile handsets. So, like you're holding like this rather than for the headset. And they support the web as a first-class citizen, and it works really well there.
Great, thank you so much. I think it's really interesting to see platforms like Zapper that mix both web access and native access into a single platform. I mean, obviously, for a lot of customers, the goal is to reach as many people as possible, and in some ways it doesn't matter to them which distribution pathway they take. So I think it's interesting that that you've built something that has both of those as sort of part of the core idea. They're not distinct.
Yeah, I think part of that for us, our technology has been built in a way that means we can deploy it in these different ways, which I suppose I'd like to say we'd planned from the start, but actually is just a kind of happy accident of the fact that we were building this technology for very constrained devices in the past, and it means that it works well on the web now. We see an increasing use of the web for AR content, and the benefit of not having to publish and host an app in an app store, it really makes a big difference for lots of AR use cases. But we work with some fantastic businesses who have great app ecosystems, and that they seek to boost those ecosystems with AR content, and get the mutual benefit of hosting that content within their app ecosystem. So, for example, 7-Eleven in the States, we power an always-on AR campaign with them, and so in their 7 Rewards app, there's always AR content to be had. And that content in the future they might wish to deliver through the web, and we'd have that option available to us. And indeed, users of ZapWorks have both those options available to them also.
Yeah, I think it's a interesting and I think somewhat unique within the context of this conversation. So I'm glad that you've been able to be here today, and thank you for being a part of this this event.
Thank you so much for having me. It's been a pleasure.
And now I think we're going to roll to Ben for a bit of talk about sponsors, and then I think I will hand it over to Ben if he is here.